providing since by providing good health to all the human beings and also nature. Friends, this webinar focuses uh, new horizons, emphasizes dynamic nature of chemistry and its impacts on a wide range of fields, including pharmaceutical, material science, energy storage, and sustainability. Energy solutions also. The platform intends to bring together scientists, budding researchers, and educators and all chemistry students to share information, promote collaboration, and bridge the gap between cutting edge research and practical applications for a more sustainable future. I would like to take this moment to express my heartfelt gratitude to all those who have taken the time to join us today. Friends, your willingness to study and improve in this industry is commendable. I encourage everyone to take advantage of the opportunity to actively participate and interact with the resource persons as we are going to face number of problems and challenges every day, and their solutions are also made by all our researchers for the sustainable development of the society and living beings. Finally, I would like to extend my warmest gratitude to all of you. Let us embark on this intellectual journey together with the open mind and common desire to pursue chemical sciences for the benefit of society. We are facing number of present protocols during the synthesis, as we have to play the uh, vital role to practice green and clean chemistry. So to this webinar will be very fruitful to the researchers and all chemistry loving friends for to improve their and also to uh, encourage themselves in the field of chemistry. Once again, I am thankful and hope that this webinar will bring a very fruitful and uh, uh, visionary information by these resource persons, and I hope you will interact with them and be connected till the end. Thank you.
Thank you, sir, for giving your presidential address. Now, I request today's inaugurator and keynote speaker, Professor Dr. Kishore Chikliya, sir, to give the inaugural speech and keynote address for this national webinar. Before to start his lecture, I introduce Professor Dr. Kishore Chikliya, sir. He is working as a professor in the Department of Chemistry at Veer Narmad, South Gujarat University, Surat, since the academic year 2017. Prior to this, he was the professor and head department of chemistry at Gujarat University, Ahmedabad. He has total teaching experience, 36 years. He has successfully guided 30 students for PhD degree and 17 students for MPhil degree. He has published more than 150 research papers in reputed national and international journals. His H-index is 26 and citations are 2,602. He has delivered number of lectures and invited talks at national and international conferences. His main research area is the development of bioactive scaffolds by various cross-coupling, CH activation, synthetic strategies. His group has developed a CH activation protocol, including alkylation, olefination, and arene-mediated functionalization through arene, carbene, and radical to get sp3, sp hybridization, CHNH, and olefins. In vast zone of CH bond activation, the functionalization of proximal CH bond has gained the utmost popularity. His latest contribution in the field of CH bond and bond formation using various bioactive moieties. With this brief introduction, I request Professor Dr. Kishore Chikliya sir to deliver his talk on this occasion. Over to Professor Dr. Chikliya sir.
Thank you very much, sir. Good morning to one and all. Thank you very much, Principal sir and the authorities for inviting me and to introduce me. First of all, I will ask all these our faculty members that we'll talk about some of the basic organic chemistry, organic synthesis. My talk will be covering of a organic synthesis. In a simple one point, I'd like to tell you that some of the reactions which is discovered before discovery of electrons. At that time, the concept was there, and that conceptualized still is working. So my talk will start with the oldest reaction, that is of a Woods reaction, Ullmann reaction, followed by some of the latest, that is a CH functionalization reactions. So in my general observation, I have found, when we ask an interview or somewhere else in a people, suppose, very common question I'm telling you, suppose ethyl chloride is subjected for treatment with the NaOH or base, I am getting CH3CH2OH. Likewise, suppose chlorobenzene is there, the chlorobenzene is subjected for condensation with the NaOH or base, I'm expecting phenol, but that reaction is not possible. But I'm getting sometimes the absurd answer, it is a very simple reaction, chlorobenzene to phenol is very easy, but it is very, very difficult reactions. So in this context, keeping this point in mind, my entire things will be based on this one. As just now Principal Sir has narrated, okay, this is a country needs a good chemistry, and we have to sustain here. All the times there is a circular from the government of India and government of our state government that you have becomes a sustainable. So what becomes a sustainable? What is our contribution in a development of these molecules? We are chemists. So our contribution to develop a nation, so we have to find out good methodologies that can be economically affordable, or it's some green route we are finding out. So with your permission, I'm sharing some of my screens. So may I request to screen this one to scroll my screens, which is submitted to Gaikwad sir earlier. Gaikwad sir, can you share my screen?
Yes, yes, sir. Yes, sir. Yes, sir.
Okay, please.
Is it visible, sir?
It is visible now.
Okay, okay.
So, yes. I am audible, no, now? Okay. So let us
sir,
first, friends, I am also telling one point. Any glitches is there, any difficulties or in understanding these things, you please raise your hand and tell me so we can resolve the things so we can understand. Because this is not, I'm not telling you this is a talk or something else. It's a discussion only. Or I am sharing my things, what are the work, basic chemistry, and what work I published in some various journals. So I'm sharing my thoughts here only. Can I have a second slide, please? Next slide, please. Yes. So coupling reactions are there. With the common point, coupling reactions we say is a homocoupling in a heterocoupling or cross-coupling reactions. Okay, two fragments are joined together with the aid of a metal catalyst. So homocoupling reaction is again divided in two parts: Woods reaction, Glaser reactions, and a Ullmann reaction. You see what I told just now, before the discovery of the electrons, this reaction has come. That is 1855 Woods reaction. We studied long back in our chemistry in the 11th standard or 10th standard. A simple Rx plus sodium, I am getting plus sodium Rx, you are getting RR bond. Then Glesser and Ullmann I will discuss. So let us see this point. Next, please. So in this reaction, yes, this is a Rx plus sodium are getting a alkane RR bond formations. So this reaction is simply going for a single electron reactions. Very common mechanism for this reaction. Rx is there, nucleophile X is there, sodium radical is generated. That then R radical is generated. This radical and sodium radical is combining, and you are getting a and you are which is going for SN2 type reaction from the backside attack. So Rx is there, X is going is eliminated, and you are getting a RR bond. That is a RR bond formation. So this is a Woods reaction. Next reaction is a Glesser reaction. This is a before, this is a just I am telling you, today we are talking for a Sonogasira reaction. But Sonogasira, before Sonogasira reaction, okay, this Glesser reaction is existed, okay, where alkynes are there, copper, or air as oxidation source, and you are getting diacetyl alkyne functionalities. Simple mechanism is operated here. Okay, this is a copper iodide you are taking, COI you are taking. It is subjected for acetylene on treatment with this was dimethylamine HI. Simple one H, which is acidic proton, it is replaced with a copper, going for oxidation supply of oxygen, and we are getting one complex bridge complex between two alkyne structure in copper is generated, which is going for reductive elimination, and you are getting a bialkyne derivatives. Then this is a Glesser reactions. Based on Glesser reactions, I will talk about this some Sonogasira reaction also. But this is a very basic reactions. Next is what? It is a Ullmann reaction. Next, please. The next is a yes, Ullmann reactions. I don't discuss each point only, but I will simply tell one point. Here, oxidation state of copper is simple single electron transfer reaction by phenyl by means of use of a this one halide plus copper. You are getting biphenyl. You are getting the important point or aspect is what how the copper dramatically changes oxidation state. The oxidation state of copper is changing from 0 to 2 to 1 to 3 and back to 1. So this is a dramatically the oxidation state of copper is changing. So I'm not going to discuss it because here you can simply say X oxidative addition is there, Cu2X, again C1X is there, CY is again joining with X, and then this is oxidation state is just changes here. Next, please. So after Ullmann reactions, these are the basic reactions. Now we are talking for a hetero or a cross-coupling reaction. So this cross-coupling reactions is you are getting a RR bond. Friends, I'm telling one point. Till now, 4 Nobel Prizes are given to carbon-carbon bond formation reaction. One is a Grignard reaction. Another is a olefin metathesis, Witting reaction, and one is a Grignard reaction, Diel-Sandler reaction, Witting reaction, and olefin metathesis. Actually, this work has first started by Heck. One paper, I'm always in my lecture, I used to tell one, I remember, or I used to tell Heck chemistry. Heck was a young scientist, and after completion of his doctoral degree, he joined Becker's laboratory, where they are using acetylene to acetaldehyde by means of a palladium. As a junior chemist, he used to ask this senior peoples, but he didn't get any proper response. The role of a palladium. Yeah, himself, he's grilled himself, and at first he's developed catalyst, palladium catalyst. And the first paper was published in 2019 to 72. That is the first paper of a Heck. That is a Heck reactions. But the Heck reactions, then later on, many scientists have started working because in our chemistry we find one person is working one bond formation was a novelty in chemistry is generated because starts working for other metals or other things. They are finding some devices. They are finding some of the methodologies are changing, oxidants are changing, some conditions are changing, and they get the compounds. So first paper of Heck was published in 72, and consequently, aged within 4 to 5 months, he has published about 6 to 7 papers in Jacks and Jocks. But his work was identified in 2010. And 2010, by the award of a Nobel Prize to 3 scientists, so Negishi, Heck, and Suzuki. And then we people started working on a cross-coupling reactions. Later on, cross-coupling reaction has given a concept of a CH functionalization reaction. So this is a today in today's area, we can find one point. If I take earlier time, simple ethyl chloride to ethanol is possible. Chlorobenzene to phenol is not possible. But when you're going for preparation of the Cl2OH, you need to go for electron withdrawing group at ortho and para position. Suppose you have a orthonitrophenol, orthonitrophenol is prepared. Chlorobenzene to phenol is not possible. But if I have orthonitrophenol, the orthonitrophenol is converted to orthonitrophenol. If I have 2,4-dinitrochlorobenzene, we can get easily at about 30 to 40 temperature 2,4-dinitrophenol. If I have 2,4,6-dinitochlorobenzene at room temperature, I am getting 2,4,6-dinitrophenol. So first of all, man has to finding out what is the beauty of a nitro group. But when we are writing the structure, resonance structure, we find when electron withdrawing group at ortho and para position, we get maximum resonance structure. That is a older concept. And we find one line, satisfy one line. If electron withdrawing group at ortho and para position, we get maximum resonance structure. That's why reaction is possible for electron withdrawing group. But later on, this entering nitro group is very hazardous. That's why new chemistry is developed. That is a Suzuki reaction, where simply one line I have mentioned this point, Rx plus Ry, you are getting RR, where X is equal to simple halide, CLBR, halides or pseudo-halides, CLBRI, OTF, like that, OTS, pseudo-halides. And the metals are there, that is of a palladium, rhodium, nickel, Fe, copper. Particularly, this one coupling partner, that is of a Suzuki is there, we are using boron, Negishi, we are using zinc, Kumada, that is a Mg, Muharsi, that is lithium, and likewise, these reactions, reactions are, many reactions are there, but their function is just to go for a carbon-carbon bond formation reactions. Next, please. So, next, please. Yes. So, what is the common feature of this reaction? Here, metal is there, is subjected for oxidative addition, and by oxidative addition, the metal changes oxidation state from 1 to 0 is there. It is going for 2 like vital only. But first feature is what of the reaction is what? Oxidative addition, transmetallation, reductive elimination, you get the product. This is the feature of these reactions. Feature of this reaction is this only. Next, please. It's a very common reaction. Next, please. Yes. So it is a simple timeline of a cross-coupling reactions. I don't waste more time for this one. You can start this point in 1990, 1910, 20, up to 2000. How many reactions are discovered? That is a brief history is mentioned. It is, you can see this later on, but so I don't discuss more things, but it's a timeline of the cross-coupling reactions. Next, please. Yes. So I'm briefing this point. Okay, Negishi is there. There is a zinc. Just like earlier we have seen, Stele is there, metal. Suzuki, boron has used. Sonogasira, copper has used. Buchwald, CN bond formation reactions. Likewise, this is a summary of these various cross-coupling reactions. Next, please. In all this reaction, they are going for a common feature, that is oxidative addition, transmetallation, reductive elimination, and get the product. Now, let us see the basic chemistry of palladium. Why I'm taking palladium, friends? Remember one point, it's a 10 group elements where palladium, platinum, nickel is coming. In this palladium is there 10 group elements. Here is what? PD, it is mentioned PDL4. L4 means each PD is a number is a 10, and each ligand donates 2 electrons. So total magic number is 18. I'm telling one point, when you're teaching the students catalysis, what is the definition of catalyst? It doesn't participate, but it accelerates the rate of reactions. But I like to extend one point here. Okay, here in this case, it is catalysis is stable, it will not work. If it's unstable, then it will work. It is stable, we can say it is a resting stage. So resting stage means we can have to just, it is resting stage, means it is inactive, but it is to be made active. When is it activated? So it just dissociate in one. That's why one picture is mentioned here, 18 electron system, this case is stable, that's not reacting. So if you go for dissociation, its second step is what? This is 16 electron system. One ligand is lost because this is 16 electron system. Ligand is neutral. Oxygen state is a 0 only. Again, one ligand is lost. So it is a PDL2. That is a 14 electron system. The 14 electron system, still it can lose the ligand, but it's a threshold level. So it will not go for dissociation. At this place, I say this is a threshold level where it is going for oxidative addition. RX is added, and a PD last structure is this one. A PD2 is generated. That is a oxidative addition when oxidation state of palladium is changes from 0 to 2. Next, please. So common feature is what? They are going for two systems, oxidative addition. This is a simple, no, back this one. Back, please. Yes. PD0 is there. Oxidative addition is there. So each AR and X share a pair of electron. So it is going for oxidative addition. So PD is converted from 0 to 2 oxidation state. That is a oxidative addition. Next step is, next please. Next step is what? It is a transmetallation. It is a very common reaction. RM1, M2, both trans is there, the cross is there, and you are getting M1 is going with the R dash and M2 is going with the R. Now, this both are transmetallation step. Next step is going for reductive elimination. Next, please. Next step is a reductive elimination. So, the reductive elimination, the palladium 2 is there. By reductive elimination, again, it is getting back to 0, and you get the product here. XY is a product of this. So, this is a very common reaction. Next, please. So, in these reactions, first reactions, I always tell this is a TAC reaction. Today, friends, this is olefin plus iodobenzene, and the first paper is published in a GOC, that is a 1972. It is the original work of a hack. Today, we people are going for a sterile derivatives or olefinics, these bonds, when we find a simple Novelgen type reaction or carbonyl Novelgen type reactions, where we are active group is there. It is subjected for condensed with aldehyde and we are getting sterile. But that time, he has developed this reaction. So this is a very common mechanisms. Everybody must be teaching this point also. PD0 is there. Common point is the for palladium chemistry is there. Resting stage, miscade is not working. It is dissociated. So then it's working. So likewise, this is a PD2 is here. OACD is there. So PD2 is there. PD0 is this one. Next is going for oxidative addition. This RX. So 0 is converting into 2. And then it is going for coordination chemistry is taking place. See, insertion reactions, this pi bond is going to this one structure palladium, first coordinate, and then strong bond is generated. It is internal rotation taking place, subjected for, vice versa, subjected for beta hydride elimination. We understand we are incorporating here Hoffman rule also. So that is going for acidic proton is lost here. So this is a beta hydride elevation takes place, and correspondingly, we are getting a olefin here. And this rest is what palladium is separated. Palladium is going for next palladium cycle, and we are getting a palladium. We are getting olefin here. Sterile derivatives, olefin we are getting. Stilbene derivatives we are getting. Next, please. Next reaction is what? That is of a Suzuki reaction. Friends, this is a very interesting point. I have written directly reactions of this one boronic acid or boron pinacol. But here, we simple find, just as a layman person, what we understand, first one is that RX, and second, it is written as a boron. Actually, how this boronic acid is prepared, take a bromobenzene, go for a grignard, that is MgBr, then go for a MgBr is going for hydrolysis. So this is going for Br is there, and one boron trichloride is BCl3, we are adding, followed by hydrolysis, and we are getting a boronic ester or boronic acid. This boron is this one, is going for it's treated with a base. So boron will not sustain more and more negative, phenyl nucleus does not sustain more and more negative charge. So boron is displaced and reaction is occurring, and we are getting a RR bond. Actually, Suzuki reaction, it is the basic reaction for a cross-coupling reactions, where you use the palladium catalyst, and it can be recyclable. It remains active for numbers of recycle cycles. But important point is that you need to go for only C. Bromine is there, Cl is there, I is there. But from experimental and a kinetical acidic effect is confirmed. The bromine is there, it is going for midot, going for boron chloride, and it forms a boronic acid. And we see this point here. Boron is there as a lab and is a basic chemist. He's just writing boron electronic configuration 1s2, 2s2, 2px, 2py like that only. And then enter the NaOH and whole reaction is carried out prince of a base medium. So boron will be, it's not sustained bore, that's why detaching and a ring becomes a activated. It is attacking to palladium and we get the cross coupling reactions. Next, please. The next is a probably yes. Our my contributions in a 2013-14. I prepare. I am basically I did some of the medicinal chemistry. Okay, where this is cyanide chloride or triazine is a very basic molecule, and we understand point. A simple three Cls are there. It is can easily be replaceable. So first Cl replace at 0 to 5, second 35 to 45. But my purpose is it is a simple nucleophilic reaction. But here in this reaction, we have done some of the CC bond formations, and we got this one. One paper has come in a medicinal chemistry long back in 2014. Next, please. Now, next point is of a sonoglycerol reaction. What I told you earlier, it is a Glaser reactions. It is a modification of a Glaser. Original is of a Glaser reactions, but here a simple sonoglycerol reaction. Simple chemistry is here: palladium and copper. Palladium 0 to 2 is there. 0 to oxygen state is there. Oxidative addition is there. Then acetylene compound is there. Where you see this point, copper, right? Is simple to understand this point. We know go for a cuprous. It's U plus 1, 3D10, 4s1, like that we can write. And then you can see here, okay, this coordination bond of pi bond is coordinating there, and a copper is changing is its position. RC triple bond CH. Then next is RC triple bond CU. When reaction is treated with a base and Cu is electropositive metal, carbon becomes an anion, and that anion is attacking to palladium, and we get some of the product that is this is a acetylene compound we are getting. Next, please. So these are the basic reactions. Now, based on these reactions, how can research can be accelerated, or research, we can do research keeping this point in mind. So one, I have taken one molecule that is a 4,7-dichloroquinoline. Everybody knows this chemistry, 4,7-dichloroquinoline. What I did here in 4,7-dichloroquinoline, fourth position is very susceptible for nucleophilic reaction. So it is a block with a morpholine. Seventh position is left, that is Cl, that is to be activated. So this is, we have gone through acetylene compound, and we got some acetylene compound at this position. Beauty of this reaction is that we simply taken these reactions in a palladium only. We have not used any copper chemistry here. And here in this case, see this mechanism here. The palladium 2 is there, ARX is there, palladium 2, coordination chemistry, that is of AR, C triple bond C. They are going for coordination, reductive elimination, transmetallation, reductive elimination, and we got the product here. And that paper has in a chemistry select in 2017. Next, please. Yes. So I'm not going for a cross-coupling reactions. This is simply 2-3 examples I have shown you. But in today's chemistry, these reactions are just, we can say it is a depleting, not depleting exactly, but there becomes an old one. A new concept is coming. And you must be knowing, we are well aware. Okay, suppose we see one paper is published in one journal, that after 2-3 months, you will find it is a very old work. So always man has to keep out finding something new things, what we can do, contribute new things. So that's why the old chemistry is little bit, it becomes old. So we say one word that is a disadvantage of cross-coupling reaction. So what are the points which make it as a disadvantages? The disadvantages means what? Okay, both coupling partners must be pre-activated. Very heavy materials or hazardous materials, organic materials like boron, tin, silica, Mg, Zn is required. The introduction of the halide or pseudo-halide group itself is not a trivial, often requiring several steps and suffering a regioselectivity problems. Now, it is longer extent, it is not very atom economic. That's why these reactions are being modified. That is of a CH functional reactions. Friends, I'm telling you one point. Next, please. I'm telling one point. These reactions right now in a current scenario, okay, what is next is what is the current scenario here? CH functionalization. So I have written one line here. Okay, one is a traditional number A and B, traditional cross coupling reaction. This is first a metal is there. Yes, H is replaced with the X. Again, it is converted to metal. Again, metal is there. Minus MX. As a layman can understand this point, MX is eliminated and we are getting carbon-carbon bond. But today's trend in a chemistry is what? Is a simple H to be functionalized. Molecule is there, X or H is there. Both H is there, and that can be eliminated. That is H2 is eliminated, and we get a carbon-carbon bond. Now, this is a single step. No free functionalization of CH bond is required. So this is a concept of the CH functionalization reactions. Next, please. So this is a simple yes. Two benzene. Nobody has seen this chemistry. When two benzenes are there, just add transition metal and you are getting biphenyl. This is the one mechanism is found here. There is OACT is there, RH. Friends, listen one point here. Here in case palladium 2 is there. If I add RX, but then each R and X share a pair of electron, their oxidation status changes from PD2 to 2 more is added. So 2 becomes a 4. 1 is there, it becomes a 3. 0 is there, it becomes a 2. But here in this case, you see this point, if PD2 is there, if I go for RH, no change in oxidation state because they are not sharing pair of electron. So oxidation state remains PD2 only. It is next step is transmetallation. So back to 0, reoxidation is taking place, and PD2 is we are getting back. So these are things only. So remember one point, when halide is used, so then they share a pair of electron and the oxidation state changes. But when RH is there, H is there, they will not go for sharing any electrons. There is no change in oxidation states. Next, please. Actually, friends, I am showing you one point that what is the basic chemistry for these reactions? What is simple feature of these reactions I'm telling you? One benzene, other benzene, you are getting biphenyl. That is a CH functionalization reactions. This transformation involves numbers of good chemistry. That is a reactive intermediates. As we have been teaching our students, that is a carbocation chemistry, carbanion chemistry. Like this chemistry is there. So where which bond is generated? This is a this point we are learning. Here in this case, I have written 4 5 lines for this one, and I'm trying to show you how CH functionalization reactions are carried out. We are learning some carbenes. I'm telling one instance. Suppose very common example I'm showing you that where phenol is there, and a phenol is subjected for Riemann reaction, and we are getting a orthohydroxybenzaldehyde, right? So we say it is a salicylaldehyde. And in this salicylaldehyde reaction, one carbene is generated. First base is there, it is treating with a chloroform, carbanion is generated, CCl bond is eliminated, and carbene is generated. Immediately the question arises, carbene is going for attacking to the OH group. And that is an electrophilic or nucleophilic reaction. We ask the student, or we sometimes we are understanding if this is a carbene is there, the carbene is a neutral species. What way it is going as an electrophilic reaction? So we try to understand, we try to discuss this chemistry. Likewise, one carbene is there. Carbene is also divided in 2 parts. One is a singlet and triplet. So a question arises, are singlet carbene works or triplet carbene works? Or if single carbene works, what is the mechanism? Triplet is there, what is the mechanism? We are trying to understand these points. Because sometimes in my laboratory, when I keep some reactions, so we are confusing, are the singlet carbene singleted or reactions we don't get it. So we try to go for a triplet state. We are using something, the argon or neon chemistry, gas is being, reactions kept in certain gases, inert gases. When we make it triplet, and we just try to find out are the reaction is occurring in singlet step, singlet carbene or triplet, and then we establish the mechanism. This is a simple feature of these reactions. So in this context, I'm telling you one point here. The mechanism of transition metal catalyzed mediated CH bond cleavage can be classified into 2 categories. One is an inner, see, this is a very interesting point. This is an inner fear mechanism that involves formation of a CM bond, carbon metal bond species. And other is there, other sphere mechanism that do not. Means they are going for a insertion reactions. Now, the first one is there is inner sphere mechanisms is divided into 5 parts. See, this reaction is of a internally we divide into. I try to mention this point. Okay, one is going for oxidative addition. First is oxidative addition. Second is a electrophilic substitution. Third one is a sigma bond metathesis. CMD, that is a concentrated metallation, deprotonation. And the fifth one is a 1-2 addition reaction. This is a outer sphere is there. It is simple for a insertion type reactions. Next, please. So, please next, please. Yes. See this point here. The interesting point is this one only. The first is going for oxidative addition, right? RMX is there plus RH is there. RMX oxidative addition. So this is a one dotted bond is mentioned M and R, where M, R, M, H, this one, X is separated here. Here is mentioned is 2 arrows, means there is a both cation and anion. Another case is there, this is oxidative addition. We are getting R, H, M, and X. Another is there electrophilic addition, substitution reaction. So you can find here, okay, one M is making bond with H, and X also try to share electron pair with H. And this is generate, this both are sharing electron pair. We say is a electrophilic substitution, and we are getting LMHR and XH. Next is what is a sigma bond metathesis. Sigma bond metathesis you can find here. RMR is there, and X and H is bond generated. Metal H bond is not found here, and you are getting MN and XH bond is generated here. One is it is a concerted reaction. CO2 is there. CO2 is added here. Loss of CO2, and that is a decarboxylation, and when RML is generated. And next is what is a 1-2 addition reactions. So these are the 5 points or mere pillars for these reactions. And based on these reactions, we are going for we have to find out, we are capturing to what type of reactions we have to do it. I am telling one point, these are the features which are kept in mind, and based on these concepts, we have tried to go for a heterocycle compounds, and we tried to develop the methodologies. Next, please. Yes. So this is a metallocarbene or insertion reactions. It is a simple formation of carbene or nitrine. So it's a biomimetic mechanisms here. MFR this one, and RXH is this one, and another is a insertion reaction. Next, please. This is outer sphere mechanisms. Now, methods for selective CH bond functionalization reaction. Here, what are the features of these reactions? That is inbred electronic properties, intramolecular reactions, directing group strategies, steric properties, and ligand control strategies. These are the main pillars of methods for CH functionalization reactions. Another is just direct CH functionalization, sterically controlled CH functionalization, CH functionalizations of ionic intermediates, and via radical. Next, please. I'm just showing some examples that will make it clear. Yes, this is a very important reactions. It is simple reaction. You see this structure here only. I don't write these things what it is written here, but simple structure you can see this point. The cyclometallation reaction is what? DG is necessarily a directing group. You always going for directing group. Directing group is either electron withdrawing group or donating group. This simply is written as a direct group only. Vicinal position is what? H is there. One H is rotated with a dark line, and RH is there. Metal catalyst is there. The first DG is there. This is the one lithium chemistry. Methoxybenzene is there. We are going for treatment with lithium. So one H is being snatched from the ortho position of a methoxy group, and there they are going where a lithium is just inserted, and how the coordination takes place. Same chemistry is taking place here. DG is there, directing group. When H is there, we are treating with a metal catalyst. So this H is being activated with a metal only. And that is going functional group here, CM functionalization. So this DG is there, when metal is there, the metal is lost here, and the functional group is entered here. You can see this is a gamma functionalization product. So functional group is being entered here. So this is the base direct sync bond functionalization reactions. Next, please. So in these reactions, one of the most successful sterically controlled safe functionalization is the EDTC, friends. There are various groups compounds, just like iridium, rhodium, ruthenium. These compounds are best for going for this one. This is a functionalization reactions, because since they involve in carbene, nitrogen formation reactions, isocyanates formation reactions, and they go for a functionalized reactions. I'm not going to read this point because all this chelating complex is there. But let us see some reactions. Next, please. Yes, it's very interesting point in this one. We can find this reaction. The first reaction you see, R1, R2, R3, H is there. First, we simply say both same structure, but to distinguish R1, R2, R3, I made it R4, R5, R6. First, H is lost. H is lost as a minus or plus that you have find out. It's a hydride minus H is there, so this becomes a plus charge. And the second one, H minus is there, so it becomes a what it is a this is a H is lost, H minus is lost, so it is a plus charge. Plus is lost, it is a minus charge. And both carbonium plus charge and minus charge. When both plus and minus combine, because we under organic chemistry we see a deficient minus is there, it requires a plus charge to get balance, and plus is there, it requires minus charge to get balance. And this compound, carbon-carbon bond formation is taking place both within cation and anion, and we get this species. For what are the precursors for carbocation and anion? That is, you can see the left-hand side, all electron donating groups are there. The donating groups are facilitating this carbocation center precursors, and we get this. These are for the facilitates this for carbocation, and anion charges are there. Also, withdrawing groups are there. They are facilitating its anion formations, carbon anion formation, carbon anion, or we say it is a carbon anion precursors. Next, please. Yes, this is the reactions. Simplifying. See, this is a simple reactions. Like here, radical is there. One H is being detected. X. See, the first case I'm telling you, XY is there. Y is detached here. One radical is generated. That radical in the second step is transferred with the H of these other things, and both radical combine, and we are getting one FG functional group is being entered here. This is a XH, and one functional group is being entered here. Likewise, other chart is this one. You can see this point. RH is there. Everybody knows this point. So one radical plus charge, radical cation is going for coupling with cation, radical cation, plus both this one, and we are getting R1, R2 cation positions. Likewise, second reaction, it is of a anion, and we get the compound final product that is a anion. Next is what? Radical, and a radical, we are getting one bond. And one next last is what? Olefin, and we get some radical transfer mechanisms. So these are the basic features, they're the basic concepts. Friends, and why I'm discussing this point, because based keeping this point in mind, we can design molecule and we can have a good publications. So for getting a better publications, you need to understand everything. All points are to be considered, found, because I have published some papers that is taken in a simple molecules. Next point, please. Next, please. Yes. Now this is a simple reaction, CDC, cross dehydrogen coupling. Just now I told you, HH is lost. So one is H is a cation plus charge, one is a minus charge. They're lost, and we get the product. Now here in the case, the transition place, transition metal or organic metal reactions, just like NOPS, SC, tellurium, both bond formations, two different stage bonds. One H from XH from these other things, and going for a HH is lost. And here this reaction is known as a CDC reactions, cross dehydrogen coupling reactions. Next point, next please. So yes, just is a very basic point is mentioned here. You can see this point is CH, and both as CH is this one, where one is a minus, both are minus charges here. Transition oxidant is added, and this compound we are getting. And in this case, we simply find delta minus S carbon is this one. Oxidant is there. So what oxidants we are taking? We are oxidant, you can say metal complex, transition metal is entered. The CMH bond is this one. One is going for cation, and other is going for radical. That is, see, these are the intermediates. These are all three. Middle one is written. It is a complex, metal complex, carbocation, carbon radical. They are combining with other CH bond. This is the intermediates which is being lost, and we are getting a CC bond, carbon-carbon bond formation reactions. So these are the internal features, internal intermediates is generated, and that is combined with the other molecule. Then we are getting CC bond formations. Please, next, please. Yes. Now this is one is there. This is a very common reaction, please. The cross hydrogen coupling via ionic intermediate. This you can see here. One metal is there. The metal is joining. We just really find nitrogen is a pair of electron. There is a metal is there. There is a metal plus charge cation, which is losing one H. And by losing simple is a hydride elimination. Vicinal H is going, and we are getting a double bond. And this double bond is reacting with the other metal, and metal is being, we say the metal is being inserted, and we are getting ionic intermediates. Likewise, nitrogen, same is oxygen, same is going for a single electron transfer mechanism. That's why I'm not repeating this point. Based on this concept, see this point. Here in this case, we are taking dimethyl malonate. My purpose is to tell one point here. This is the middle one, CH2 group is there. It is an active ethylene group, where it is combined with the oxygen, vicinal to oxygen, just like an isoquinoline type nucleus is this one. And we get one new bond, that is a red color bond is mentioned. CC bond formation is there. The similar is the second one is there, this molecule, and we are getting some CH functionalization reactions. Next, please. So this is a reaction. You can see this point here. In this reaction, please see, this is one H is here, one radical is here. You can see this point, one radical, other radical, and this we are getting these reactions. And we carbon-carbon bond formation is very, very basic chemistry. We find open chain structure is there. It is getting closes. It is going to cyclization reactions. I'm telling friends, one is simple going for when we are teaching the students on attachment reaction for getting coumarin. So we simply ask the students that we are taking resorcinol, ethyl acetoacetate, phosphoric acid. We try to explain this chemistry. What is the role of the phosphoric acid? Some books it is written polyphosphoric acid. So what is the role of a polyphosphoric acid? In absence of polyphosphoric acid, we are going for sulfuric acid, and we try to explain them how this is a ring gets cyclized. Simply in this Feshman reaction, cyclization is what? Elimination of carbocation, generation of carbocation. It is being attacked with the ring, and we get the compound. But you just compare this example with a Feshman reaction and this example, the first one is written. Here, we don't have to do in these reactions for the other steps. But a one-pot reaction, simply add catalyst and you get a cyclization reaction. That is the only purpose. That's why I simply have written a indole structure we are getting in a one-pot reaction. It is mechanism is mentioned here. A tertiary butoxide is there, is going for radical transfer. Radical transfer is there. One radical is generated, and this radical is being combined with an aromatic nucleus, and we get a one red color bond. CC bond formation is there. That is the beauty of this chemistry. Rest of the groups remains intact only. Next, please. So just see this. This is I have taken it from a when a book short is taken. It is simple carbene formation. Carbene generation is there. Now we understand how carbenes are generated. They are from hydroxide compound also. They are from diazo compounds also. They are from some numbers of ways where carbene reactions are there. They are going for migratory insertion reactions, alpha elimination, beta eliminations. That is very simple common features. I'm not going to read it again, but it is the one chart is mentioned. You can see this point. There are various ways for generation of the carbenes. Next, please. So next, based on this reaction, I'm telling, yes, next, please. I'm trying to show one point here. Okay, decarboxylations. Friends, this is just now I have published one paper that I'm going to discuss with you, because right now, if functionalization chemistry is so advanced, if you see in the chemical reviews, there are 2 to 3 reviews articles based on CH functionalization. So one thing we imagine, what are the work papers are, what are the work we are doing, and these reactions are occurring. So that my carbon dioxide carboxylic group is there. The carboxylic group is going for a decarboxylation, and we give it a compound. Next, please. So I have just taken one example that is on a coumarin. This one, see this point, coumarin. This is very interesting chemistry. See this point, coumarin 3 carboxylic acid, and we understand simple, just as a layman person, we find benzoic acid. In benzoic acid, if you are going for decarboxylation, so there we are simply hitting with a line. So carbon dioxide is eliminated, and we get the decarboxylation reaction. But here I tried to do reaction with coumarin 3-carboxylic acid, where a pyrene nucleus is very susceptible to do reactions by simple radical transfer mechanism. The carboxylic group is there, pyrene structure is there, and that is condensed with a thiazolidinone. Now, this simple thiazolidinone, we understand, every researchers understand how thiazolidinone, everybody is maximum in India, people are working on heterocyclic chemist. They must be knowing thiazolidinone is an intermediate of a penicillin antibiotics. That is a simple feature of this penicillin. Okay, the penicillin structure contains one thiazolidinone. How it is prepared? You take a aniline, amine, aldehyde, skip base, and a skip base going for condensation reaction thioglycolic acid. You are getting methyl group is there, active methylene group in place of COS and this one active methylene group is to be explored. So this is decarboxylation group and one group is entered. Friends, I'm telling you, very simple catalyst I have used. Copper is this one, copper to butyroxides, where one radical is generated at active positions. Coumarin 3-carboxylic acid is there. Simple, you can find this is CO2 butyroxides, COO, COX, going for elimination of a CO2, carbon dioxide is eliminated. And you see this point, a copper 2 complex is generated, and that is reacting with the radical because copper is a one stage here, and it is going for one stage, one radical is generated, one radical of copper and one radical of a thiazolidinone active methylene group. Both are combined, and we get one bond. That is a beauty of this chemistry, and a new bond is generated. There is a carbon-carbon bond formation reactions. Very, very simple chemistry, and there is a one-pot reaction. Is simply in one pot you put coumarin 3-carboxylic acid, thiazolidinone, copper catalyst is used, and I just heated it. We got this compound for 18 hours. Based on this one, a radical coupling reaction is there. We kept one reaction with a radical for conforming this reaction. NMR, this was characterization is done. But for more understanding the mechanism, we kept this reaction in a radical scavenging experiments. That is a tempo, BHT is used, where we have found if this yield is less, no product is generated because radical is generated, it is being scavenged by means of a tempo. That's why we confirm it is a radical transfer mechanisms. Next, please. So based on these compounds, one of my students is found, we have found that coumarin 3-carboxylic acid is there. Why we don't go for sulfoxamine chemistry? Sulfoxamine, you know this sulfur drug is there. Everybody is using sulfur drug, but sulfoxamine we have taken, and this is going for these reactions. And that paper has commented letters. There is a copper catalyzed decarboxylic coupling reactions between coumarin 3-carboxylic acid with a sulfoxamine. Same chemistry is there. Instead, we have taken copper acetate, also going for CO this one. And here in this case, copper tertiary butoxide is there. It is going towards tertiary butoxide is there. It is going for radical transfer. That radical is being captured by SO2NH group and a big radical transfer, and we get this molecule that is a sulfoxamine derivatives. Again, copper is left, and that is going for further cycle, used for next cycle. Also, this experiment we have confirmed with a radical scavenging experiments. Next, please. So you can see this point. What a basic chemistry. We have written one review also. Okay, we got some of the successful results. This one. So I asked my students to go for one review. They have one review is written on decarboxylic reactions that has come in chemistry lab. Next, please. Next, please. So yes, metal catalyzed sulfonations. Now, friends, one point I'm telling you, thioethyl linkage is very interesting chemistry because to get a CS bond, next, please. Yes. Next, please. Keep on this one because something student has prepared a CS bond, CSC bond. Many of the drug molecules, yes, many of the drug molecule, they have a silent features of a CSC bonds. And how this CS bond is generated, that is of a dimethyl sulfide, sodium methyl sulfide, methyl Na2S, thiourea, mercapto compounds, and free sulfur. That is a sulfur is abundant in our air, in our nature. So we have numbers of dyes industries. So we have taken S8, that is elemental sulfur. And the elemental sulfur is used for CS bond formation. Next, please. Yes. So these are the simple reactions. I'm just summarizing this point here. X is there, where how many people has work? This work is going from a 78 onwards. That's CS bond generated, mercapto compound, casein, sodium thiolate, sulfate. This is boron. This is there are various reactions. They have got it. One just now in a 2018 one paper, 19 paper has come that is of a mix. This is the pyrimidine compounds, microcycle compounds, where sulfur is generated. But what I did based on these reactions, I tried to go for a CS bond formations. Next, please. How CS bond formation is taking place? So metal-based sulfonation reactions. Next, please. Next, please. Yes. Why is sulfur is used? Because it is a low cost, less toxicity, easy to handling, and absence of odor. We get this molecule. Here, the feature is simple sulfur S8, which is a, you can say it's a waste material, where is going for is a catalyst. Sulfur dimer is generated, going for oxidative elimination, elimination, and you get the product. Next, please. See this next, yes, yes. So this is a very simple things I'm telling you, friends. Here, S8 is there, using a cuprous iodide, CUI, dimer is generated. It is subjected for condensation with a paramethyl iodobenzene. One dimer is this one, and you can see this point here. One dimer SS bond is generated. Just one complex is generated, and that complex is the capacity. They are going for one oxidative addition. That copper is going for oxidative addition. CUI is there. Now you can find this CUI is generated. Halide is this one. This one is a 2 is generated, and it is going for CUSH. CUI is eliminated. PHS dimer is there. PHSH is paramethyl. The mercaptone is eliminated, and we get this one CS bond formations. This is a very beauty of these reactions. Here we got a CS bond formation simply by dimerization reactions. We got it when with the logic we are taking some paramethyl iodobenzene. Why? Because paramethyl iodobenzene, the yield is increased. We have gone through various electron withdrawing group, donating groups, and confirmed a donating group is there because of the methyl group is there. Methyl group have got a maximum yield rather than other donating group that is of a OCH3 and other groups we have taken donating group, we got a less yield. So there's a confirm one point, methyl group is there, paramethyl, because of the hyperconjugating effect, we got a maximum yield. Next, in this context, one more thing is there. I'm simply telling one point. Next, please. So in this in continuation with these reactions, we have taken other molecule that is of a hydantoin. Hydantoin is simple. This one you can see benzylamine is going for thiourea, and we get a disthiourea. Simple, you can take benzyl, you are amine, go for THF, and one go for xylene. We get a corresponding thiourea and disthiourea, and disthiourea go for cyclisation with a potassium thiocyanate. You are getting a hydantoin. My purpose is to show one point. Hydantoin is there, civil structure, but where I don't see the other things. I find only one point, that is an active ethylene group. And same chemistry, and we got one paper that has come in a Indian Journal of Chemistry. That is a good journal of a NISCAR of Government of India. Next, please. Next, please. Yes. Next, yes. This is a, friends, it is a very interesting chemistry. Thank you. This is a very nice chemistry where a simple molecule in continuation of the thiazolone reaction, dimerization reaction. Friends, I tried to go for a quasi-benzylic acid intramolecular rearrangement. Everybody knows this benzylic acid rearrangement. I simply taken this molecule, and in this molecule, we have taken dimerization, but only the benzyl bromide, paramethyl benzyl bromide is taken instead of paramethyl iodobenzene. Only one benzyl CH2 group is entered. Purpose is what? If purpose of benzyl group is there, benzyl, this common, say up to 3 steps is very common. But benzyl bromide is there. In this benzyl bromide, one H is active, and that is treated with a base which is snatching one H from this methylene group and generates a carbon ion. Now, this carbon ion is attacked into the electron deficient carbonyl compound, and what is cyclisis is taking, where it restores its aromaticity and subsequent loss of water molecule, and we get one thickened ring. Friends, I'm telling you, you see my paper just now. It has 15 days back. It has come in. It has 15 days come. It has come in tetrahedron. But see the chemistry is a benzylic acid reagent. You must be teaching colchicine chemistry in our students. And there also we find what way a seven-membered ring is contracted to six-membered ring. We're simply showing it by double bond is generated, diketone is generated. It's going for benzylic acid reagent where a ring is being contracted. When you're talking some natural product chemistry, there also we find this one retin chemistry is there. It's also going for the same chemistry, and we get ring contractions taking place. So that is the rearrangement I have done here. Please see this mechanism is here only. Next point here. See, friends, my purpose is to tell one point. Those who are newly researches we are assembled here, and we required some publication. So what way we can do publications? There is a big problem of a state universities of fund as well as chemicals. So from the easily available chemical, we apply our chemistry and we try to do the best things. While writing these papers, what I have found, we have generated a Thetan ring. So what the Thetan ring is generated? So we got this idea. I have summarized some of the Thetan compounds which has a biological potential because the purpose is to prepare some building blocks. So various Thetan rings, that these are the, you can see in my paper, I have mentioned everything, but there's various Thetan rings we have collected, and then we found that these molecular building blocks, if I prepare, same molecules, if it is prepared by 4 to 5 steps, why don't I prepare in a one-step reactions? That is the things only, beauty of these reactions. Because we understand point, when we are submitting paper for publications, they are always telling what is statement of novelty. At that time, we are showing these features. Next, please. Our latest other contributions in ion chemistry. So, friends, one point is here. With this paper has in chemistry select here. Same molecules as already known. Where I have gone through one, oxime is there. Metal oxime. We understand the ketone is there. The ketone is going for oxime. The oxime is going for radical transfer mechanism, and we got this one heterocycles here. Next, please. This is also pyrazole compound. Chemistry is same. I don't discuss more things. This is the same chemistry. Here also one simple example. I have taken a 2-chloro, 2-methyl, 3-carboxyl group is here. And that is 3-methyl orthohydroxy compound. Only the feature of this reaction is what? By means of copper, we have taken this one, cyclization is taken, and we got a furan ring. Here in this nitric acid is there. Very simple. Nitric acid is available in our every laboratories, where a copper complex formation is there. And that is going for this mechanism, and we are going for a this reaction is going for these reactions, and we got a furan ring. That chemistry has paper in a heterocycles. Next, please. Yes, this is a good chemistry here in the olefins and acylation processes. This is a very good chemistry, friends. Here is a orthochlorobenzaldehyde or orthohalobenzaldehyde. It's subjected for hydrogen, and we got a one imidazoline ring, heterocycle chromino imidazoline ring is generated. We see this point. Our work is what? Simple hydro. See this point. And we got this last, our work, you see this one, A, B, and C. B, our work is there. We are orthochromobenzaldehyde. It's we got some chrominofused rings, imidazole rings. Just next, please. I have mentioned it is a cascade reaction, friends. No, it is okay. Okay, let's discuss this point. Hydrogen is this one. We are going for a cyanomethylation reaction. So simple compound, we are going CH3CN. We are finding acetonitrile is a solvent only. But solvent is reacting. What a beauty of this reaction. This is the old molecule we are taking, as already known. We are simply CH3CN. It is going for radical transfer mechanism. Solvent itself is trapping a radical, and we got a cyanomethylation reaction. And this paper has come in a tetrahedral letter. So you can see this point here. This is here. Please, what has happened? It is not screening not found. Please, sir.
Sir, your screen is not visible, sir.
How it has happened? I have not done anything. Just can you do it again?
No,
I have
sir.
not done it. Internet connection is not there. It's not interrupted.
Sir, your PPT is visible, sir.
I'm not seeing. What happened?
Sir, is it visible, sir, now?
No, still not.
No.
No, I'm not quite to find. What has happened? I don't know.
I think there is some technical problem with Gaikwad sir. Gaikwad sir. Who is
Yes,
operating
now it is okay. Yes, now it is okay.
Okay,
Please,
sir.
yes, correct. Thank you, sir. Thank you.
Okay.
So in this case, C3CN is there. You see this point here. The C3CN is there. It is also going beautiful chemistry here. Radical is there. And is one O, double one O is making complex with the copper. Then generation of radical. Again, this radical is combining, and we can find CH3CN cyanomethylation reactions. This is the chemistry of TBBP. So all these peroxides, even our hydrogen peroxide and some of the peroxide, they are going for radical trapping mechanisms, and you can prepare it. And when you're getting publications here. Next, please. Sir, next, please. Yes. Here also, people are thinking, what about second position? See this case, you see this molecule. This has also come in tetrahedral letters here. This simply taken acetanilide, 2-chloro-3-formyl quinoline structure, which is going forward. Cl, second position Cl is there. That is Cl is to be explored. We have done this chemical reactions here, palladium compounds, and we got a dimerization with same function. But that concept I have shown, that is of a free sulfur. Another molecule I have taken that is of a mercaptan compounds directly thiophenol. The thiophenol is going for this chemistry, and we got a CS bond formation. That has come in a paper that Next, please. Yes, this is a good chemistry, friends. I'm telling you. Here, OTF and TMS is there. It is a good option of a benzyne. And we are getting benzyne. It's a very tough mechanism, not tough mechanism, but it is simple. Arine is there, and arine is being inserted, and we get a mechanisms. Instead, we can go for some, because time is a little bit less, we can go for some other things also. Let us go for next slide. Next slide, please. This also, yes. Very good chemistry is occurring here. Here is also the orthobromochlorobenzene. We are finding out selectivities, and based on this one, this is a very crucial mechanism is generated where coordination is taking place, and we get the compound. But more slide one I would like to go for. Next, please, sir. This is also a similar type of the compound, but I'm not going to discuss this point. Next, please. One interesting mechanism. Yes, this paper has come just now in a Sinlet. This paper is just now it has come in a Sinlet. I'm telling you one point here. This is a copper catalyzed reactions we have seen. Now we are talking from the iron catalyzed reactions. Fe is there. Fe is also going for trapping the reagents, and we get a compound. And here in this case, a simple compound has known is hydrogen is taken, which is subjected for acetyl oximes to get some ion derivatives. We got it. This has come in a Sinlet. Next, please. One cascade reaction I wanted to show where it is found. Next, leave this place, sir. Sir, leave this. One next, please. Next, sir. Yes. So in this reaction, sir, you see this point here, the active methyl group is there, where acetylene is to be added. And that we say is a sp3 sp hybridization. sp3 sp hybridization, where a C carbon bond formation is there, and this reaction is acetylene group can be entered to these positions, and we get the molecules. You see this point here. This is also going for a peroxide. This is we are learning what's DDQ reactions or radical transfer mechanisms. That DDQ is applied here, is going for DD type reactions, that is of a Fe molecule is used, and Fe is going for coordination with a triple bond, and it traps one radical, and this radical combine, and we get these molecules. That has also come in tetrahedral letters. Next point, please. Next, please. Yes. As we have seen, let's back. As we have seen, sir, please, friends, back. Yes. As we have seen, this is a one radical is just one activity is left. Where also we can go for a C3CN, and we got a cyanometallation reaction. And this is the mechanism for this reaction. But that is, see, the previous one is generated by means of a copper. Here in these reactions, we generated by means of a Fe. So keep on changing the catalyst, find out this catalyst, and we get a numbers of derivatives. Next, please. Based on this reactions, friends, I have tried to, next, please. I have written some of the reviews I have written. This is mentioned here only. So one message, yes, metal-free reactions. So friends, my message to you that when you are going for, I'm just starting this one. When you are going for various reactions, and we get a good publications, all fellow colleagues, you must be listening one point that we always for promotion, not for promotion, but for our satisfaction, for our students who pursuing under working under you, you need to give some ideas. We go for some basic chemistry, explore basic chemistry, and you can get a good publications. So this is the message. This is something I stop here. Now I'm very happy to discuss with any question is there, please.
Participants, you please ask any difficulty, any query regarding this lecture. Is there any question? You please ask. The session is open for discussion. I hope that there is no any query, any suggestion, any question about your lecture, sir. Sir, thank you for delivering.
Sir, I have shared. If anybody wants a PPT or something, they can communicate. They want to discuss something. They are always welcome. My mail and everything is with you.
Okay.
Please, you are welcome.
Okay, sir. Okay,
Professor Chikliya, sir.
Yes, sir. Yes, sir.
Congratulations for a very excellent and nice lecture you have delivered.
Nice of you, sir. Thank you.
Very nice lecture, sir.
One
query I want to put before you.
Yes.
Your research is very excellent as you have published in very reputed journals, every papers we saw.
Thank you, sir.
In brief, for audience, will you put the applicability or applicable part of your research in practice? In short. Hello?
Yes, sir. Yes.
In short, just as a conclusion.
Who, me?
Hello? Chikliya, yes, sir. Just I request you.
Yes, sir. Yes, sir.
I request you explain in brief the applied part of your research as you have presented many number of papers before the audience.
Yes. Oh, yes. So listen, friends. My applied part conclusion is what? You just try to develop a molecules, find out a suitable molecules where it has applications, where a chemistry can be explored, and you can go for a basic material which is available in market, which is cheaper, and then you can explore the chemistries. So in this all reactions, I have taken a very simple molecules. I have taken a simple thiazolidinone, which is available. In short, I'm telling you, since professor is expecting something, so what I'm telling you, you take a simpler molecule, and explore good chemistry. Either you say old molecule, new chemistry, or new molecule and old chemistry. That is a crux only. But best one, my suggestion is what? You take an old molecule and explore new chemistry. So that is a service to the nation. And our aim is to go for an environmentally benign reaction, which is economic reaction, is to be explored.
Thank you, sir. Thank you.
Okay,
Thank you, sir.
Okay,
for
sir.
delivering very nice lecture and informative lecture, sir, by
And
you.
it's so nice of you, sir.
Yes, sir.
And
Yes,
nice
sir.
to all. Thank you very much, management, Gaikwad sir, and the principal sir, and the authorities of Bid College
Thank you. Thank you, sir.
for giving expo, for listening me. And I'll always be. I'm delighted to be associated with you, sir. Please tell me any sort of help is required from my side.
Sure, sure, sir. Sir,
So
very
nice.
soon we'll try to meet physically on the
Yes,
occasion of
please.
any conference or seminar at our
Oh, so
place.
nice. Thank you, sir. Thank you. Bye bye.
Sure,
Shall I
sir.
leave? Okay, sir.
Yes, sir. Thank you very much, sir.
Okay, I'm leaving
Thank
now,
you,
sir.
sir. Thank you, sir.
Okay, sir. Okay.
Thank you, sir. Okay, sir. Okay, sir. Now we have next resource person, Professor Captain Dr. Suresh Gaikwad, sir, Senior Professor, Department of Chemistry, Dr. Baba Saheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar. Now I just introduce Captain Dr. Suresh Gaikwad, sir. Suresh Gaikwad, sir, has teaching experience 36, 35 years. Research experience is 26 years, and he has done an administrative services in the Dr. Baba Saheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar as a director for the student welfare, director for pre-IAS coaching, controller of examination, registrar, BCUD director, head department of chemistry. He has as a KCC officer as the holding the rank captain. He has social achievements. He is the chief coordinator of Awan 2009. That program was conducted by Chancellor's Office.
शॉर्ट मध्ये प्रोसिजर आहे का
Swami Ramanand Tirth Marathwada.
Please put mic
प्रोजेक्ट वर
off,
along with
off
two
all
estimation and two
participants.
preparations. Right?
Participants
There are two projects. First one is
please.
the preparation of orange second, and second thing is the dyeing of fabrics. म्हणजे एखादी डाय तुम्ही
Participants
आपल्या
are requested to mute yourself, please. He has got an award, Vishwanayak Kranti Prerna Puraskar, Guru Gaurav Award, Devang Mehta National Education Award, Bharat Ratna Dr. APJ Abdul Kalam Award, Most Fabulous Professor by World HRD Congress 2020, Mumbai. He has published 96 very good research papers in reputed national and international journals. He has presented 64 papers in national and international conferences. He has attended 70 international and national conferences. There are 3 books on his credit. He has delivered 55 invited lectures in the seminar, refresher course, orientation course. 8 students are working as a PhD work under his able guidance, and 7 students, they have awarded PhD degree under his able guidance. With this brief introduction, I request resource person, Captain Professor Dr. Suresh Gaikwad, sir, to deliver his talk, and the title of his talk is Ancient Indian Technology in Metallurgy. Over to Captain Dr. Suresh Gaikwad, sir. Please.
Thank you, Dr. Milind Gaikwad, sir, for my nice introduction in front of audience.
Thank you, sir.
Very good afternoon to one and all.
Good afternoon, sir.
As we have assembled here for a second session, already we all have enjoyed first session, which is delivered by my friend and a great teacher and scientist, Dr. Chikliya sir, for 1 hour. And for this session, we have Shri Prakash Solanke, who is the chairperson of MSP Mandal, Honorable Satish Bhau Chauhan, who is MLC, and Secretary of MSP Mandal, Chhatrapati Sambhajinagar, President of this webinar, and my friend, Principal Dr. Gopal Kakade sir, Vice Principal and convener of this webinar, Major Dr. Milind Gaikwad, Vice Principal, M.A. Jogde sir, and all the participants, those who have participated for this national webinar. So once again, good afternoon to one and all. And already most of my time has taken earlier speaker, and that's why I try to conclude within a stipulated time. I will not take much more time. And as per the discussion made in between the principal, vice principal, convener, and myself, are you audible? My noise?
Yes, sir. Yes, sir. Yes, sir. You are audible, sir.
Okay, may I continue, sir?
Yes, sir. Please continue.
Reactions are characterized by.
So this national webinar is conducted by Marathwada Shikshan Prasarak Mandals, Rajmata, Jijau, Mahavidyalaya, Kille-Dharur, District Bid. And I'm happy to be a part and parcel of this webinar because for a few years, around 2 years, I work in this college as a professor. And then again, I came back to Balvin College Bid. But I was very much associated for these 2 years, this college, and not only two years, but I am always associated with this institution because my native place is Port Pimpri, and which is near Dharur, Kille-Dharur. So deliberately, I have chosen this particular topic after the discussion with Professor Kakade and Professor Milind Gaikwad. That is New Horizons in Chemical Sciences, and my topic, ancient Indian technology in metallurgy. So as you all aware about the National Education Policy 2020, and in last year for PG courses and for undergraduate courses, this year we have implemented this particular policy. And under this policy, as per the Act uh, sanctioned or granted by the Parliament of our India, and it is bound to implement for all educational institutions and universities. And that's why this particular aspect is deliberately they have introduced in the syllabus or curriculum of graduate as well as undergraduate and postgraduate courses. And that's why we'll discuss on this particular issue, that is ancient Indian technology in metallurgy. Actually, metallurgy part is the main theme of my lecture. But before that, I want to put before you the earlier development in metallurgy in our India particularly. All over world, there was a introduction of this particular technology, but particularly in India, what was happened, that I want to put before you. Now, you see this particular slide, you can have a little bit idea regarding the theme of my lecture. And these are the important points. What are the
Sir,
outcomes?
Sir,
Yes,
one
sir.
minute, sir. Your slide is not visible, sir.
Okay, okay. I will see. Yes, sir. Is it visible now?
Sir, it is not visible, sir, till now.
अरे पुन्हा एकदा जॉईन व्हावं लागेल बहुतेक ना.
Join हो, sir, double नाही तर मग. Sir, you have post. You can share. Yes, sir. Yes, sir. Yes, sir. Now
Yes,
it
sir.
is visible, sir. Yes, sir. Now it is visible, sir.
Okay. Okay. Okay.
Nice, sir. Okay.
So to understand the term Indian knowledge system, and that is IKS. In short, it is known as IKS. As rightly now I said, this particular issue is deliberately introduced by our Ministry of Education in the curriculum of undergraduate as well as postgraduate courses. So first of all, you try to understand what is the need to understand the IKS. Then classification framework of IKS, and then we'll see some examples of IKS. Get introduced to the overall organization of the Vedic corpus. Then we'll see familiarize with our Vedas and their subcomponents. Then we'll go for recognition the multi-faceted nature of the knowledge contained in Vedic corpus. Now you see what is Indian knowledge system. First we'll have to try to understand. भारतीय प्राचीन ज्ञान परंपरा ज्याला आपण मराठीत म्हणू शकतो. द रिच हेरिटेज अँड नॉलेज क्रिएटेड अँड अक्वायर्ड बाय इंडियन्स ओव्हर सेव्हरल मिलेनिया in the Indian subcontinent. Indian knowledge repositories. Repository, it is nothing but the storing of knowledge. Systematized knowledge, that is with respect to manuscript and shastras. Then we will have a traditional knowledge in with respect to the oral conditions, folk songs, stories, arts, handicrafts, and traditional skills. So in the form of all these particular things, our Indian knowledge system exists. Now you see this slide, you can observe many of the pictures in front of you, and you will find this is the wheel. Actually, this is the Sun Temple, which is in Orissa. This is the statue of Nataraja, and some are temples, some are the symbolic pictures, and some are the buildings. So all these things are very ancient type of things. It means in the history of India, these particular things, these are the representative picture actually. But all these things were exist in history of India. And it gives us idea, even though in the ancient period, there was a development of science and technology. Because without development of technology as well as science, this could not be possible. So everything is possible due to some knowledge, due to some technology, which was available in that particular period. So these are the representative examples in front of us, and such a type of thousands of monuments are there. So thousands of caves are there. Some thousands of ancient symbols are there, which gives us an idea regarding the developed science and developed technology in the ancient period of India. Now, this is the major source of ancient Indian history. Actually, I want to put before you all these particular classification because you may have idea archaeological sources, and then this is literary sources. This archaeology sources in Marathi or in Hindi we can call it as a Puratattvik Strot. ज्याला आपण पुरातन काळातले काही सोर्सेस म्हणू आपण. सो दिस आर्कोलॉजिकल सोर्सेस आर इन द फॉर्म ऑफ चित्रकला, मूर्तिया, सिक्के, अभिलेख आणि स्मारक, ज्याला आपण जुने काही स्टॅच्यू म्हणतो किंवा काही ड्रॉइंग म्हणतो, काही स्टॅच्यू असतील किंवा कॉइन्स असतील, आणि जुन्या काळातलं काही दस्तावेज असेल ज्याला अभिलेख म्हणतो आपण. सो all these comes under this particular archaeological sources. And you might be knowing that Archaeological Survey of India is the biggest department in our country, and everywhere, even in Chhatrapati Sambhajinagar, you see there is Ajanta, Ellora, Bibi Ka Maqbara, Panchakki, and many more number of things and many more number of places are there which is under the supervision of this archaeology department. Actually, these things gives us a knowledge, all type of knowledge. When we enter in a Ellora or Ajanta, we can have a lot of knowledge, we can achieve many more things. We try to collect in we can say sculpture or caves, and how it is existed still today also they are in good condition. And in the form of literary sources, we may have Bharatiya Sahitya, Videshi Sahitya, and this can be we can say classified like this. And this is in many way we can say Sangam Sahitya, Aitihasik Grantha, Dharmik Grantha, Bodha Sahitya, Jain Sahitya, Brahman Grantha. So according to all these books and all these literature, we can have an idea regarding the knowledge which was available in thousands years back, and many more years it was available in our India. Then we can say this is Videshi Sahitya. So I will not read it. This slide will be with you all participants later on, and you can read it. But this particular classification is important when we are trying to recognize the knowledge available in our India. And again, this particular, we can say Brahman Granth, this is again classified in subclasses like this: Ved, Brahman Grantha, Aranya Grantha, Upanishad, Vedang, Upved, Mahakavya, Puran, Smruti, even Manusmruti is also comes under this particular. What is bad, what is good, how it is applicable, how it is not applicable, how it is faithful, how it is we can believe, not believe. That is not the point of my lecture. But this particular thing is available in the form of literature and one of the source of knowledge, and even this also. So in all, we can say lot of things are there in our India in the form of literature, in the form of archaeological monuments, and even today also we are having the references of all these books. Now I will focus your mind on this particular picture. This is the picture of actually yoga, and it indicates the unlocking the ancient secrets of Indian happiness. As generally it is saying that in all over the world, India is yoga guru country, because we are trying to spread this particular yoga in all over the world. And you might also aware about that. Few years back, our Prime Minister Narendra Modi have focused on this particular Yoga Shastra. Just for I am putting these slides in front of you. That is examples of knowledge system, and that is ancient knowledge system of our area. That may be in the form of Vedas, Upavedas, and Vedanga. So under Veda, it is generally said that this is the ocean of knowledge. म्हणजे ज्ञानाचा सागर आहे असं आपल्याकडं म्हटलं जातं, की आपल्याकडे जे काही पुरातन गोष्टी आहेत तर त्याला आपण ओशन ऑफ नॉलेज असं संबोधलं गेलेलं आहे. अँड दिस वेदांगा इज ऑल्सो, अँड they are having the numbers. Even applied knowledge of technical work is also there, that is in Ayurveda, and all these type of knowledge system, Dhanur Veda, Gandhara Veda, as well as Sthapatya Veda. So these are comes under the technical type of knowledge, of technical work knowledge. Even this particular thing is also established in our country in thousands years back. Again, this is also called as the examples of knowledge system, that is IKS, Indian knowledge system, Upangas and Kala. Under this, it comes instruction manual and explanation of the progress of gaining the knowledge, that is Puran, we can say, Nyaya, Mimamsa, Dharma Shastra, and under Kala, nowadays we are always talking about the skill development program. So in that period also there is a skill and art initiative to human being, and this type of things were available in our ancient India knowledge. Again, I want to focus on this particular tree. So this is a tree of Veda actually, and this is received by rishis and complied by Vyasas. Okay, so they have put in the form of literature. So as you might be aware, you might be read somewhere Rig Veda, Yajur Veda, Samveda, and Atharveda. So these particular four parts of these trees mentioned here, and every part they are having this type of sub branches. Now, question arises regarding why do we need to invest in IKS, as even Parliament of our India unanimously granted this particular new or national education policy 2022, and we have already implemented it. And you see, in every curriculum, there is an introduction of this particular IKS. So obviously, there is a question arises why this particular investment we are doing. So paucity of genuine scholarship in the field, which leads to propagation of myths and unscientific claims, isn't it? म्हणजे ज्याला आपण श्रद्धा अंधश्रद्धा या नावामध्ये मोजतो, तो प्रत्येकाचा पार्ट वेगळा आहे. दॅट इज द इंडिव्हिज्युअल असेसमेंट विच इज गुड, विच इज बॅड, विच इज नोन एज श्रद्धा, बिलीव्स, अनबिलीव्स, and all these things. I am not going into deep in this particular aspect, but students as well as teacher fraternity can think the realization regarding the myths and unscientific claims. Even critical need of educational institutions to take leadership in understanding and researching the scientific and technological heritage of India. So that is our duty to propagate this particular thing, which is good, which is bad, and our students are quite ahead than us, and they can easily realize which is good and which is bad, and which is scientific and which is unscientific. Actually, there is a big scope in this particular Indian knowledge system. Whenever we are not reading anything, we cannot say which is scientific, which is unscientific, which is believable, which is not believable. And that's why we can say there is an Indian way that is both sustainable and strive for welfare of all. So the ultimate aim to learn each and everything. Behind that, there is a sustainability and strive for welfare of the common person. Now, with the help of this particular slide, you may have get good idea regarding the significance of IKS division or MOE, Ministry of Education vision. What is the vision behind introduction or implementation or inculcation of IKS in the curriculum of graduate and postgraduate education? So very nice thing is mentioned here: promote interdisciplinary research on all aspects of Indian knowledge system. And Ministry of Education, regarding the IKS division, they have mentioned their vision and mission like this, or particularly the vision. So vision of IKS is nothing but to promote interdisciplinary and transdisciplinary. So we'll have the another step ahead, one step, that is transdisciplinary research on all aspects of Indian knowledge system, that is IKS, and update and disseminate IKS knowledge for further innovation and societal application. So the society is in front of us, or society is at the center. The welfare of society is at the center of Ministry of Education, central government of India. Vision of IKS, that is SAKEC, this particular word, SAKEC. So this gives us idea, providing a learning environment for the exploration of our ancient sculptures and connecting with the present domain of our discipline studies to develop the products, applications, and practices with artists of enhancing the life of people and society. Now you see, you try to get the meaning, literal meaning of each and every word. So you will get realize that the aspect of vision of this particular IKS is nothing but the development of each and every stakeholders, right from the citizen of India, students, teachers, scientists, and everyone. So this big vision is of Ministry of Education in front of the society, in front of the Indian people, and that is in the medium of IKS division. So finally, again, we'll have to have a highlighted points, preserve and disseminate Indian knowledge system for further societal applications. So whatever societal need is there and whatever you are thinking, so it should be focused on the applicable part of society or societal application. It should be applicable for the common person and for the common society person. Now, few of the slides are there. So this is regarding the NEP 2020, and on the occasion of this particular presentation, as the role of IKS by Ministry of Education in the form of vision, the rich heritage of ancient and eternal Indian knowledge and thought has been guiding light for the policy. So this is considered as a heritage of ancient India, and it should be passed on to the present society or the today's generation or the next generation. Definitely, we all will hope in this introduction of IKS system in NEP 2020, it will be much more beneficial for the upliftment of teachers, students, as well as overall society. Now, in Hindi, it is deliberately I have mentioned राष्ट्रीय शिक्षा नीती, ज्याला आपण नॅशनल एज्युकेशन पॉलिसी 2020. कुठल्याही देशाचा विकास जर आपल्याला पाहायचा असेल, त्याचं डेव्हलपमेंट पाहायचं असेल, त्याचं भविष्य पाहायचं असेल, तर त्याला कुठली तरी नीती लागते. आणि तसंच आतापर्यंत सुद्धा काही एज्युकेशन सिस्टीम होत्या, नॅशनल एज्युकेशन पॉलिसी नव्हती अशातला भाग नाही. याला आपण नॅशनल एज्युकेशन पॉलिसी 2020 म्हणतो. याच्या अगोदर सुद्धा पॉलिसी येऊन गेलेल्या आहेत. त्या काळामध्ये काळानुरूप त्या एज्युकेशन पॉलिसीने त्याचं कॉन्ट्रीब्युशन हे दिलेलं आहे. बट what will be the contribution of this particular national education policy, and it is very easy to understand, which is mentioned in Hindi. प्राचीन और सनातन भारतीय धन्या और विचार की समृद्ध परंपरा के आलोक में यह नीति तैयार की गई है. Now I will mention some of the name of the university, that is तक्षशिला, नालंदा, विक्रमशिला और वल्लभी. जैसे प्राचीन भारत के विश्व स्तरीय संस्थानों ने अध्ययन के विविध क्षेत्रों में शिक्षण और शोध के ऊंचे प्रतिमान स्थापित किए थे, भारतीय संस्कृति और दर्शन का विश्व में बड़ा प्रभाव रहा है. So you might have read somewhere else about the history of education in India. Once upon a time, students from all over the world, they are coming to India. भारतामध्ये येत होते लोक, हे सगळ्याला माहित आहे. आणि आपल्याकडे अतिशय वर्ल्ड क्लास युनिव्हर्सिटी एस्टॅब्लिश होत्या, बुद्धकालीन युनिव्हर्सिटी त्याला आपण म्हणतो. तक्षशिला असेल, नालंदा असेल, आजही नाव तुम्ही ऐकत असाल, विक्रमशिला असेल किंवा वल्लभी सारखी युनिव्हर्सिटी असेल. आणि त्याच्यामध्ये आता सध्या बिहारमध्ये माननीय पंतप्रधानांच्या नेतृत्वाखाली नालंदाचं रिएस्टॅब्लिशमेंट चालू आहे. जवळपास ते आता होत आलेलं आहे. सो दॅट विल बी इंडिकेशन फॉर ऑल ओव्हर द वर्ल्ड की आपण देशाला एज्युकेशन मध्ये आपण लिडरशिप करत होतो एकेकाळी, भूतकाळामध्ये, इन एन्शियंट पिरियड ऑफ इंडिया. याचाच अर्थ नॉलेज आपल्याकडे कमी नाही. जसं आज everybody wants to learn in foreign countries. Somebody wants to go in UK, somebody wants to go in Russia, somebody wants to learn in America. So that particular trend was established in ancient period of India. People used to come to India to learn. It means you can get realize that what was the standard of our education in that period. So these are the best examples of ancient knowledge which was available, which was established in such a type of university. भारत का ज्ञान में आधुनिक भारत और उसकी सफलताओं और चुनौती के प्रति प्राचीन भारत का ज्ञान और उसका योगदान शामिल होगा। विशेष रूप से भारतीय ज्ञान प्रणाली को आदिवासी ज्ञान एवं सीखने के स्वदेशी और पारंपरिक तरीके सहित कवर किया जाएगा। सो दिस विल बी द ऑब्जेक्ट इन आवर फ्यूचर, इन आवर एज्युकेशन सिस्टम। भविष्यामध्ये आपल्याला काय करायचं, व्हॉट वी वांट टू डू इन फ्यूचर. So all these aspects we want to introduce in the coming fourth generation, so that they should not forget the earlier very golden history of knowledge of our India. और गणित, खगोल विज्ञान, दर्शन, योग, वास्तुकला, चिकित्सा, कृषि इंजीनियरिंग, that is called as agricultural engineering, भाषा विज्ञान, साहित्य, खेल के साथ शासन, राज व्यवस्था, संरक्षण आदि विषयों को शामिल किया जाएगा. सो दिस विल बी द ग्रेट विजन ऑफ मिनिस्ट्री ऑफ एजुकेशन टू इनकलकेट दिस इंडियन नॉलेज सिस्टम और द करिकुलम ऑफ इंडियन नॉलेज सिस्टम in each and every class of graduate as well as postgraduate classes. Now you see, this is the statement of some philosopher, some examples of Indian knowledge system which reflect by a single line. Spirituality is not adopting more beliefs and assumptions, but uncovering the best in you. So this particular statement realize the real meaning of Indian knowledge system. म्हणजे बुद्धाने जसं सांगितलेलं आहे की आत्मदीप भव, स्वयंप्रकाशित व्हा. स्वयंप्रकाशित व्हा म्हणजे तुम्ही नॉलेजनी एवढं तुमच्याकडे नॉलेज असलं पाहिजे की तुम्ही नॉलेज ज्ञानाचे सागर असला पाहिजे, एवढं ज्ञान तुमच्याकडे असलं पाहिजे. आणि ती खरी स्पिरिच्युअलिटी आहे. स्पिरिच्युअलिटी आपण दोन्ही गोष्टींना देर आर टू वी कॅन से फेसेस ऑफ कॉइन्स. जसं नाण्याच्या दोन बाजू म्हणतो आपण, तसं आज आपण अर्थ त्याच्यातून काय काढतो, व्हॉट वी आर टेकिंग द मिनिंग ऑफ स्पिरिच्युअलिटी. स्पिरिच्युअलिटीला आपण मराठीत अध्यात्म म्हणतो, पण अध्यात्म कधी कधी दोन प्रकारचं आपल्याला पाहायला मिळतं. त्याच्यामध्ये श्रद्धा आहे आणि त्याच्यामध्ये अंधश्रद्धा, अशा दोन प्रकारचे. सो आजचं जनरेशन, टुडेज जनरेशन कॅन अंडरस्टँड व्हेरी प्रॉपरली which is good, which is for the welfare of person, which is for the welfare of society, which is for the welfare of common man who is needy to develop themselves. Now you see one example I will give. Such a type of ample number of examples are there. This is ancient Indian calendar. So in that period also there was a calendar, and with the help of this calendar, so people were used to prepare their day-to-day activities. So this was introduced in 79 CE. It means that particular century, and which was by Saka adopted in 1957, which is known as Gregorian calendar, and its year was 1592, and which was introduced by the Pope Gregory, that is known as ज्याला आपण 13वे पोप म्हणतो. तर त्यांनी हे इम्प्लिमेंट केलेलं आहे आणि त्याचं अडॉप्ट केलेलं आहे किंवा त्याचा समाजाला उपयोग झालेला आहे. आपल्याला आजच वाटतं की आपल्याकडे कॅलेंडर आहे, आपण 10 वर्षानंतरच बघू शकतो, 10 वर्षापूर्वीच बघू शकतो, 100 वर्षापूर्वीच बघू शकतो, 100 वर्षानंतरच बघू शकतो. बट इट वॉज एस्टॅब्लिश इन आवर इंडिया ऍज ए कॅलेंडर, अँड विच इज नोन ऍज एन्शियंट इंडियन calendar. Now only two examples I will put in front of you, and that is the picture of Ajanta and Ellora, because these examples are from our area, and that is from near by Chhatrapati Sambhajinagar. So this is the great monuments, and the Chhatrapati Sambhajinagar become a world heritage, or these places become world heritage due to these Ellora and Ajanta. You see this particular picture and this Kailas Lene at Ellora caves. Now you see, whenever you are visiting Ajanta as well as Ellora, particularly at Ajanta, so there is a decoration of these particular monuments, or the decoration of this particular Buddha Leni by some paints, and thousands of years back it was prepared by that particular generation. So we may have one question in front of us or this is a question of common man. So without science or without technology, it could be possible to establish such a type of monuments? So answer is definitely no. There was a knowledge, there was a technology, and that's why it could establish in that particular ancient period. Now we are having machineries, but that time there was no machinery, but there were the skilled person available. There were some equipments. With the help of which equipments, such a type of stone were made, such a type of historical monuments in the form of Ajanta as well as Ellora. If we take a round for complete chaos or Ajanta area, so that time in front of us we will have a big question. It was a really miracle or it was really surprising things. And as on today also, it is established 100% foolproof as it is. There is no any type of deterioration, and everything is available for study. So it reflects that these are the two examples, but thousands of examples, lakhs of examples in our India. Every state there are some specific monuments available and which is made by the people, and definitely we can say these people were trained and they were knowledgeable. They have some technology, they have some engineering mind. Now we look to the very important aspect in our life, that is water cycle. And this physics in Vedic corpus, it is mentioned. If you try to realize or if you try to have a find out the meaning of all these things, it is quite difficult for us because we don't know everyone the Sanskrit, but little bit we can easily understand if you read this, and the meaning is also here so that we can understand. This is a collision of cloud precipitates in the form of, ज्याला आपण पर्जन्य म्हणतो किंवा पाणी म्हणतो किंवा पाऊस म्हणतो, ऑन लँड इन टू द मेजर रिझर्वायर ऑफ ओशियन, म्हणजे ज्याला समुद्र म्हणतो आपण. सब सरफेस वॉटर ज्याला आपण नद्या, प्री क्लोटेड वॉटर, डिपॉझिटेड वॉटर, हे वेगवेगळ्या प्रकारच्या वॉटर बॉडीज आहेत, ज्याला समुद्र म्हणू आपण, नद्या म्हणू किंवा छोट्या छोट्या विहिरी म्हणू. आजही आपल्याला अँशंट पिरियड मध्ये लोक पाणी तर पित होते, परंतु आपल्याला वाटतं की पाण्याचा शोध आपणच लावला काय, पण पाणी हे अतिशय जुनी गोष्ट आहे आणि पाणी ह्याला जीवन म्हणतो आपण. म्हणजे जे काही लाईफ आहे, मग ते प्लांट लाईफ असेल, अॅनिमल लाईफ असेल, वाईल्ड अॅनिमल लाईफ असेल, ह्युमन लाईफ असेल. सो विदाउट वॉटर इट वॉज नॉट पॉसिबल. So in that sense, we can easily understand the person of that year in the ancient period, they know the significance of water. आणि त्याच्या बऱ्याचशा गोष्टी मेन्शन केलेल्या आहेत. द मास ऑफ वॉटर ऑन अर्थ रिमेन्स फेअरली कॉन्स्टंट ओव्हर टाइम. द प्रोसेस ऑफ वॉटर सायकल, इव्हॅपोरेशन, कंडेन्सेशन. आणि आज जे आपलं हे पाण्याचं चक्र आहे असं म्हणतो आपण, की पाऊस पडतो, पाऊस पडल्यामुळं पृथ्वीवर धान्य पिकलं जातं, धान्य पिकल्यामुळं मनुष्य जीवन असेल किंवा प्राणी जीवन असेल, वनस्पती जीवन हे अस्तित्वात राहतं. सो दिस पर्टिक्युलर वॉटर सायकल, अँड दिस सायकल इज नॉट established today or yesterday, but it was very ancient type of water cycle, and that is particularly in the form of these three stages: condensation, precipitation, and evaporation. जसं आपण सायन्स मध्ये सांगितलं जातं किंवा देर आर थ्री स्टेजेस ऑफ वॉटर, that is solid, liquid, and vapor. And due to that, this particular cycle is going on, and it is very applicable to establish or to enhance or to sustain the nature. Now, this picture is to understand the equipments or some instruments available in the ancient period. So, will you believe without knowledge or without technology, it can be manufactured? So I will say no possibility. So there was a knowledge, there was a technology, and if you read each and every equipment, तर हे सगळे इन्स्ट्रुमेंट कशाचे तरी कामाचे आहेत. आता जसं मी इथे वाचतो, मे आय रीड इट, हे सगळे शस्त्र म्हणून त्याचा वापर केलेला असायचा. तर हे सगळे शस्त्र जे आहेत, शस्त्र म्हणजे इक्विपमेंट, जसं आज आपण वेपनला शस्त्र म्हणतो, जसं पिस्तल आहे किंवा रायफल आहे किंवा तलवार आहे, सोर्ड आहे किंवा आणखी कुठले तरी सीझर आहे. सो In that period also, this type of shastra were prepared, were manufactured by human being, but no machine was available, no sophisticated instrumentation was available. They have made all these equipments, all these shastra by their own. All are handmade. It means they know how to use all these equipments for the welfare of society, for the welfare of human being. And it indicates that in ancient period, definitely it proves there was a knowledge. And this knowledge system, we should not forget. Again, we'll come to the mission of IKS to inspire youth to take deep interest in IKS with a positive mindset. Actually, youth is in center. Our center point is youth because youth is the future of our country, and that's why it is necessary to inspire our youth. Maybe a college student, maybe a PhD students, or maybe overall the youth of our country. Youth of our country is the future of our country, and that's why we should focus on youth. And regarding IKS also, because this particular thing must accept first of all by youth of our country. And for what purpose? Enable young researcher for further study and research Indian knowledge system so that they can work their research, they can do some research on this particular aspect, and only youth can do it. To develop processes, practices, technologies, mechanism based on IKS which are used to the contemporary India. So, after all, this is the ultimate aim to, to have a contemporary India. Then develop solutions to contemporary problem based on Indian knowledge system. Whenever we are having some problems, whenever we are having some crisis, whenever we are having some questions, whenever we are having some queries, so I will tell you, or according to our knowledge system, Indian knowledge system, I will certainly give you an idea. We have a solution in our knowledge system. Just we will have to try to find out how we can resolve the issues, how we can resolve our queries, how we can resolve our problems. To develop a sense of deep pride in Indian culture, to promote patriotism, ज्याला आपण देशभक्ती म्हणतो, ग्लोबल प्रोपगेशन ऑफ इंडियन कल्चर, म्हणजे सगळ्या जगामध्ये आपल्या देशातलं काय संस्कृती आहे, काय परंपरा आहे, आपल्याकडचं काय नॉलेज आहे. सो देर मस्ट बी अ प्रोपोगेशन ऑफ दिस पर्टिक्युलर अवेलेबल नॉलेज. आणि जसं मी मग सांगितलं की नालंदा असेल, तक्षशिला असेल, या विद्यापीठामध्ये जेव्हा बाहेरचे लोक येऊन शिकून जात होते आणि मोठे होत होते की आम्ही भारतातून शिकून आलो, याचाच अर्थ काय की आपण आज प्रोपोगेशनला थोडं कमी पडतो. सो डेफिनेटली आय एम हॅव्हिंग फुल कॉन्फिडन्स with the inculcation of this IKS, we will be able in future to have a nice propagation at global level of our Indian culture. Disseminate rational basis of Indian culture. This is also one of the mission of this IKS system. Now you see this particular diagram or this picture. This is a secret science of happiness. Unlock. How can I tap into it? So yoga is a very simple thing to see or to listen or to observe, but it gives tremendous energy to the people, not only of India, but all over the abroad. And that's why we are trying to propagate, because as it is said that yoga is born in India, and that's why we want to propagate in all over the world. And obviously you might get realized that all over the world it is adopted very enthusiastically, and they are this is a knowledge system. Yoga is also one of the knowledge system, as a best example, ideal example, which is started or initiated in India. Now I will focus your mind on this ancient Indian metallurgy. Now whenever we look to the history in any particular museum we are visiting, so such a type of pots, such a type of different articles we may observe. And this is the best example of knowledge system of our India. Without knowledge, it cannot be made. हे जर बनवायचं असेल तर तुम्हाला हे काय आहे हे कळायला पाहिजे. What type of metal is this? हा मेटल कुठं सापडतो, कोणत्या खनिजामध्ये सापडतो, इन विच ओर इट इज अवेलेबल, हाऊ इट कॅन बी एक्सट्रॅक्टेड, in what way it can be prepared its pure metal, and then how it can make its alloy, and how it will be become molded, and how such a type of different shapes, different types of pots, different type of utensils they have made in that particular ancient period. So definitely its answer is they may have tremendous knowledge, tremendous type of engineering mind, tremendous type of technology, and due to that they could become successful to make such a type of things. And obviously, it is also one of the example of our Indian ancient knowledge system. Now, if you read this, so you can very easily understood or try to understood the significance of our Indian knowledge system. So this first paragraph is about that India's phenomenal contribution in the field of religion, spirituality, language, literature, philosophy, grammar, arts, architecture, etc., etc. And he is well known in the scientific field. Our contribution, our Indian contribution to mathematics, astronomy, medicine, and other allied branches are thousands of texts available in Sanskrit on different branches of science, which are yet to be published, and even among the texts which are available in print, analytical study or scientific perspective has not been done on most of the texts. It means nothing is left in each and every walk of life, each and every field of life, our ancient knowledge system entered. So that is in Sanskrit, definitely. But we'll have to again re-establish some mechanism to, we can say, extract the knowledge from this particular literature, this particular text, which is being available in our country. In even Vedic period, I want to focus, get you realize that I am not saying which one is bad, which one is good, and this is not the analytical lecture of mine. But whatever it is available in the form of knowledge, that I want to put before you, and you are free to get realized or free to decide which is good and which is bad. You are the better judges, and you can easily conclude what is to be accepted, what is to be rejected, or what is not to be accepted. Metal and gems like gold. So we are having attraction of gold, use of ornaments which is made by gold, silver, platinum, and even iron are mentioned in Vedic text. सगळ्या प्रकारच्या धातूचा उल्लेख आपल्याला संस्कृतमध्ये किंवा आपल्या ज्ञान भांडारामध्ये आढळतो. याचाच अर्थ काय की धातूचा शोध काय आज लागला नाही, हा धातूचा शोध पूर्वीच लागलेला आहे. इव्हन डायमंड सुद्धा त्या काळात होताच, इव्हन आयर्न होतच, लोखंडाच्या बऱ्याचशा गोष्टी आपल्याला बघायला मिळतात, कॉपरच्या बघायला मिळतात, झिंकच्या बघायला मिळतात, सोन्याच्या बघायला मिळतात. सो एव्हरी मेटल दे आर हॅव्हिंग सम मटेरियल विच इज अवेलेबल since the ancient period of India, and that's why we shall start with Vedas. In the Rigveda, for example, earring, म्हणजे आपण कानात घालायची रिंग आजच मुली वापरतात किंवा मुलं वापरतात अशातला भाग नाही. आपल्याला राजा महाराजा काळामध्ये आणि प्राचीन भारतामध्ये सुद्धा इयरिंग पाहायला मिळालेले आहे. नेकलेस पाहायला मिळते which is made by gold, and also with jewels are mentioned. Number of articles are available in different type of museums which is made in the ancient period of our India. It means without knowledge it cannot be manufactured, it could not be manufactured, and that's why we can conclude one thing: we have knowledge since ancient period. So this is the English statement of this Sanskrit. It is to be noted that to extract, म्हणजे आपल्या केमिस्ट्रीमध्ये सुद्धा असतं की ते कशा काहीतरी एक्स्ट्रॅक्ट करतो आपण. एक्स्ट्रॅक्ट these metals from their ores is not easy unless the Vedic people had sound knowledge of the various process of matching these metals. म्हणजे ते मेटल कुठं मिळतात, कसे सापडतात, काहीतरी टेक्निक आहे का. आज आपल्याला जर पृथ्वीच्या भूगर्भामध्ये मग आपण जर ठरवलं किंवा इथं पाणी लागतंय का नाही, तर त्याला एक टेक्नॉलॉजी आहे आणि त्याच्यानंतरच आपण बोर घेतो किंवा विहीर पाडतो. तसं त्या काळामध्ये एखाद्या ठिकाणी जर सोन्याची खाण असेल, एखाद्या ठिकाणी जर सिल्वरचे ओर्स असतील किंवा खनिज असतील किंवा प्लॅटिनम सापडणार असेल किंवा आणखी कुठला मेटल सापडणार असेल, कॉपर असेल, अल्युमिनियम असेल, आयर्न असेल, तर विदाउट नॉलेज, विदाउट टेक्निकल नॉलेज हे शक्य झालेलं नाही. अँड दॅट्स वाय ऑल दीज थिंग्स, द सिस्टीम इज mentioned in the form of literature and in the form of text. In that period, it is said, where his flesh, blood, body and the smell are compared to iron, copper, tin and lead. म्हणजे त्या काळामध्ये जसं आपण आता म्हणतो की आपल्या बॉडीमध्ये जवळपास 40-45 एलिमेंट्स आहेत, त्या काळात सुद्धा ते ओळखायचे की शरीरामध्ये लोखंड असू शकतं, कॉपर असू शकतं, टीन असू शकतं, रक्तामध्ये सुद्धा काही असू शकतं. आज आपण म्हणतो की रक्तामध्ये हिमोग्लोबिन आहे, अँड इन हिमोग्लोबिन देर इज अ सिग्निफिकंट रोल ऑफ आयर्न. आयर्न इज द मेटल विच कॅन बाउंड ऑल द लिगॅंड्स. आयर्न एक कॉम्प्लेक्स आहे, हिमोग्लोबिन एक कॉम्प्लेक्स आहे आणि त्या कॉम्प्लेक्स मध्ये मेटल आहे. म्हणजे त्या काळात सुद्धा ह्या गोष्टी माहीत झालेल्या आहेत आणि इट इज मेन्शन्ड somewhere in the form of literature. Nail cutter made of iron is mentioned in चंदोगया उपनिषद. नेल कटर आपण आज वापरतो, आपल्याला वाटतं की आपल्या वेलफेअरसाठी आपण ते तयार केलं, बट इट वॉज मेन्शन लॉंग बॅक इन द ancient history, ancient knowledge, drive home some philosophical concept in the same context, that is copper, lova is also mentioned, and one can infer the depth of knowledge on metal contained in the Chandogaya Upanishad, where it talks of alloying of the metals, it says. So, formation of alloys or mixing of 2-3 metals. Now we are doing the manufacturing of alloys, manufacturing of bimetals, trimetals, tetrametals type of mixture. But this type of alloy is already available in ancient India, maybe in the form of different type of monuments. जसं मी तुम्हाला एक एक्झाम्पल सांगेल की बऱ्याच जणांनी दिल्लीला गेला असाल आणि तिथला जो कोणता आहे स्तंभ तुम्ही सांगू शकेल?
अशोक स्तंभ.
मग सांगितलेलं एक्झाम्पल
अशोक स्तंभ.
कुतुब मिनार पाहिला असेल ना दिल्लीचा?
येस सर, आय हॅव सीन इट.
हा, तर त्या मी ह्यासाठी एक्झाम्पल तुम्हाला देतोय आणि सगळ्या ऑडियन्सला रिअलाइज करण्याचा प्रयत्न करतो की तिथे एक स्तंभ आहे अँड विच इज मेड बाय आयर्न अँड इट वॉज अँशियंट. त्या अँशियंट पिरियड मधला आहे. त्याचं जर तुम्ही थोडस गुगलवर सर्च केलं तर तुम्हाला लक्षात येईल की ते इतका असा भव्य दिव्य आहे. As on today also, it is not rusted. There is no oxidation, there is no rusting. It is intact. And that was त्याचं अशोक पिलर असं नाव संबोधलेलं आहे. तुम्ही जर गुगलवर सर्च केलं तर पाहायला मिळेल. एक एक्झाम्पल सांगतो मी तुम्हाला, असे कितीतरी एक्झाम्पल्स आपल्या देशामध्ये तुम्हाला पाहायला. सो दिस वॉज हॅपन ड्यू टू द नॉलेज अक्वायर्ड बाय दोज पीपल in that period. Another one thing I want to put before you, yet another wonderful example of the Vedic people having the knowledge of iron or steel, which was used to make an artificial lake seen in Vedas. जसं आपल्याकडे आज राजस्थान आर्टिफिशियल फिट म्हणतो आपण, तर त्या काळामध्ये लेक बनवलेले त्याचा उल्लेख आहे. सो वी फाइंड हियर द स्टोरी ऑफ क्वीन, द कन्सर्ट ऑफ खेला, who was involved in fight with enemy, that is king, fought with Oler, but in the process she lost one leg. म्हणजे एक खेळ असायचा त्यांचा, युद्ध करायचा आणि त्याच्यामध्ये तिचा पाय लॉस झाला. बट द वेलोरस लेडी prayed to the divine physician Kumaras, who performed a surgery and fixed an artificial leg to her made of iron, which was made by steel or iron, and later she conquered her enemies. So in this way, this was the thing happened in ancient India. So it is obviously without knowledge it was not possible. Now we are all aware about archaeology. Archaeology ज्याला आपण पुरातन वास्तुशास्त्र म्हणतो. So just as a mathematical and astronomical details given in ancient Sanskrit texts are compared with the modern books on these subjects, the knowledge of the ancient Indian on metallurgy and mining can also be substantiated with archaeological evidences. It is a part of sustainability actually, available from various sites. One of the findings which exists even now is standing monuments, that is 250 feet in the Singham copper mine and 600 feet vertical shaft in Hatti gold mines. And these two indicate the degree of high technological achievement in the field of mining in ancient India, at least during 3000 year ago. मी तर 1 वर्षापूर्वीच सांगत होतो तुम्हाला, पण हे 3000 वर्षापूर्वीच्या या गोष्टी आहेत ज्या तयार झालेल्या आहेत, ज्या अस्तित्वात आहेत आणि अतिशय चांगल्या कंडिशन मध्ये आपण ज्याला म्हणू की ऍज इट इज त्या तिथे उपलब्ध आहेत. Apart from archaeological evidences, we have evidences through epigraphy and numismatics. The example of Sanskrit inscription and Vishupadigiri by King Chandra, 5th century AD, and the coins of Gupta kingdom throw much light on the development of the metallurgical and mining skill of ancient Indians. म्हणजे त्या राजाच्या काळात 5व्या सेंचुरीमध्ये अशा प्रकारचे कॉइन त्यांनी वापरलेले आपल्याला आढळतात. म्हणजेच फार पूर्वीची गोष्ट आहे की ज्या काळामध्ये आपण डिनाय करू शकत नाही की हे नॉलेज नवीन आहे किंवा त्यावेळेस काहीच नव्हतं. रिगार्डिंग मायनिंग, we will focus some of the slides on this particular, which is very related to the metallurgy. But otherwise, we are thinking that metallurgy is the science which is developed in last decade or last 20 years. But it is not like that. It was developed since long ago, 3000 years ago. If the description of various ornaments, ornament म्हणजे आपले सोन्याचे दागिने ज्याला म्हणतो आपण, made of gold, silver or precious gems, weapons like different varieties of arrow ज्याला आपण बाण म्हणतो, spears असतील, messes असतील, and mechanical contrivances of many type found in ancient Sanskrit texts starting from Vedas down to the text of medieval and latter period of India are to be believed. Then we should accept the fact that ancient Indians did have sound knowledge of mining and other industries allied to it. As a sample, we can take some ideas from the Arthashastra of Kautilya of the 4th century BC. त्या काळामध्ये सध्या ह्या सगळ्या गोष्टी उपलब्ध होत्या, and that's why we cannot say this type of knowledge is a modern knowledge. We cannot say this is old one, and this is the real heritage of our India. So again, in Kautilya Arthashastra, many texts, many references are available as on today also. Just we will have to follow this particular type of literature. Now, metal and alloy, this is not the modern development of chemistry or modern development of science or modern technology of science, but it was also old one. Each metal has some specific color, texture, and nature, and those people, they get realize and they work around that. The purity of metal should be judged properly. That time also it was judged which one is pure gold and which one is a mixed gold or impure gold. So this is not the new. Now instruments are available, with the help of which instrument we can immediately recognize that gold is 24 carats or 23 carats or 22 carats or 18 carats. But that time also it was get assessed, evaluated or analyzed by the person. So this particular reference is also there of 9th to 11th century AD. Pure metal is that which when melted in crucible does not give spark, nor bubbles, nor spurts, does not emit and sound, does not show any line of the surface, but in tranquil like a gem, and this pure metal flows out from the furnace. So methods were different, but with the help of which methods they were able to judge whether the metal is pure or impure. 100% pure, 99% pure, 98% pure. but science was there. Again, in continuation, here this particular word, that is furnace, kiln, it is derived from the root and defined as the vessel which removes or destroy the impurities. आज जसं आपण एखादा मेटल इम्प्युअर असेल तर त्याच्यातले इम्प्युरिटीज रिमूव्ह करून त्याला प्युअर बनवण्याची जी प्रोसेस आहे, सो दॅट प्रोसेस was available in the record. And in order to remove the impurities which are firmly attached with ore which contains smell, these furnaces were used. The impurities are burned, being mixed with other things. Modern metallurgical science says that the organic matter present in the ore is burned and inorganic impurities are converted into slag and removed from molten metal. And in the second chapter, Arthashastra detailed description of silver, iron, कॉपर, ओर्स आर ऑल्सो गिवन. म्हणजे त्या काळामध्ये सुद्धा की मेटल मधल्या इम्प्युरिटी आपण रिमूव्ह करू शकतो, त्याचं प्युअर फॉर्म मध्ये तयार करू शकतो, वेगवेगळे मेटल वेगवेगळ्या ठिकाणी सापडू शकतात, त्याचं एक्सट्रॅक्शन कसं करा. ऑल दीज प्रोसेस वेअर अवेलेबल इन द लिटरेचर ऑफ our Indian knowledge system, and that's why you can say very firmly that the people from other countries abroad, other world, other countries from the world, they are coming here to learn the education or to take the education and to learn many things, not only in science but in languages, humanities, social sciences, in all walk of life. And they came here, they became trained, and they go back their countries and they develop their countries with the help of our knowledge. Flux also, actually this concept or this particular word is, we can feel that this is the word of our science or our chemistry, but this word was used in the literature. Since metal and impurities are difficult to be melted directly, तुम्हाला एक प्रश्न पडत असेल की in that period how they are using different type of containers, how they are performing the experiments, how they are giving the heat, how they are using that particular amount of heat, maybe after 105 degrees Celsius or 2000 degrees Celsius, but that process was established and they are using somehow. And this process was also known long ago. As we can see, this technique being described in some texts, a variety of fluxes have been used to convert impurities into slag. Archaeological excavation from many sites, like that of Rajghat copper mines, reveal that production of pure metal was in vogue during the ancient time. So this was the popular, that is Rajghat copper mines. So this is not the new one or in the modern India, but this was in ancient India established. This concept was also not new concept, that is corrosion of metals. ज्याला आपण गंजणे हा प्रकार म्हणतो किंवा this is a peculiar property of metal. Degradation of metal due to various factors like their contact with air, oxygen, moisture, acidic or alkaline material is common phenomenon. But in ancient Indians had sound knowledge of this subject. The Delhi iron pillar is the standing testimony of it. मी जो तुम्हाला जे सांगितलं दिल्ली आयर्न पिलर, जो दिल्लीमध्ये आजही जशाला तसा त्या कुतुब मिनारच्या तिथे आजही उभा आहे. कधी गेलात तर तुम्ही बारकाईने ते बघू शकता. सो दिस पर्टिक्युलर थिंग इज देअर. Corrosion of metals, which means tin, lead, and copper may be cleaned with alkali and acids. Iron, bronze, and copper alloy are cleaned with ash and water. So this particular process, this concept of cleaning and polishing, the people were known. Now, alloy making is also not new. This Indian knowledge system was already established. So I will not read every line, but the theme of this particular slide is this. The ancient Indians were well versed with production of alloy, and they were knowing each and every aspect, how to make the alloy, how to make two alloy mix with one another, and it will be applicable for a particular purpose. Now, within a short time, not more than 5 to 10 minutes, I try to conclude my talk because I think time is already over. So this is the metallurgy before and during the Harappa civilization. हडप्पा आणि मोहनजोदडो सिव्हिलायझेशन आपल्याला वाचायला मिळालेलं आहे. तर ह्या सगळ्या गोष्टी, ऑल दीज थिंग्स, ऑल दीज मटेरियल्स आर अवेलेबल इन दॅट पर्टिक्युलर सिव्हिलायझेशन किंवा त्या संस्कृतीमध्ये. Now it is very necessary to read this particular information. The first evidence of metal in the Indian subcontinent, Merga in Baluchistan, small copper bed dated 6000 BCE, before century. Then archaeological excavations show that Harappa metals Smith obtained copper ore from the Arvali Hills, Baluchistan, and beyond that. Then Harappa discovered copper and tin. There is a combination and it makes a bronze. म्हणजे ब्रॉन्झ त्यावेळेस बनलेला आहे. आपल्याला आजच वाटतं की आपण पुतळे बनतो. But in that ancient period also they make lot of statues of great personality, Devi Devatas and all these things. Harappa craftsmen also invented the true saw with teeth and the adjoining part of the blade set alternatively from side to side, a type of saw unknown elsewhere until Roman times. Whatever it is available in modern India, so I think we can say everything was available in that period also. Different type of alloys were, brass was there, bronze was there, whatever the alloys were applicable for a particular application, it was available. Even you see, this is not new. This was also manufactured, and which is a bronze speckled sphere. त्याला आपण arrow म्हणतो किंवा बाण म्हणतो. So that type of material is manufactured in the ancient period of our India. Now very few slides are left. So this picture is in front of you. That is bronze statue using the lost wax technique. हे सगळं बघा, या लेवलला ते गरम करायचे आणि त्याचं वॅक्स बनवून त्याचा ब्रॉन्झ म्हणजे त्याचं दोन आलायचं मिक्सर आणि त्याच्यापासून ते मिक्स धातू किंवा मिश्र धातू बनवायचे आणि त्याच्यापासून वेगवेगळे अप्लिकेशन तयार करायचे. सो दिस वॉज ऑल्सो ए व्हेरी एन्शियंट सायन्स वी कॅन से. आता दिस इज figure in front of you. So this is the metallurgy of Harappa civilization. हडप्पा संस्कृतीमधली ही सगळी गोष्ट आहे. So what is that? A bronze figurine of a bull, कालीबंगन, made by the lost wax process. तर हे सुद्धा कसं बनवायचं हे टेक्निक त्यांच्याकडे होतं. म्हणजेच काय, सायन्स होतं त्यांच्याकडे टेक्नॉलॉजी होतं, इंजिनिअरिंग होतं. Again this see this particular picture, and this is the metallurgy during Harappa civilization again. So this was nothing but the dancing girl of Mohenjo-daro made by the lost wax process. It means lost wax process was very established process for making different type of articles or monuments by different type of alloys. After the Harappa, also we can see this particular thing. After the Harappa in the classical age, copper, bronze, Smith supplied countless pieces of art. म्हणजे आपण हे सगळं सप्लाय करत होतो. Let us mention the huge bronze statue of the Buddha made between 500 and 700 century in Sultanganj, that is Bhagalpur district, Bihar. Now at the Birmingham Museum at 2.3 meter high, 1 meter wide, and weighing over 500 kilograms. You cannot imagine. 500 kilograms वजनाची बुद्धाची मूर्ती. So as on today also it is placed in the museum. So it was made by some lost wax technique with Harappa used 3 million earlier. 3 millennium earlier. जे बघा त्या काळामध्ये हे सगळं सायन्स टेक्नॉलॉजीच्या नॉलेज शिवाय शक्य नव्हतं. सो दिस इज ब्रॉन्झ मेटलर्जी. हे सगळ्यांना परिचित आहे. ही नटराजाची मूर्ती आहे. सो वी वेर thousands of statues made later and up to this date in Tamil Nadu, such as the beautiful Nataraja statue of the Chola period, among other famous bronzes. तर ह्या मूर्ती काय आज नाही बनलेल्या, सो इट इज ड्यू टू द एन्शियंट नॉलेज. अशा प्रकारचे मिरर, ज्याला आपण ग्लास म्हणतो, ब्रॉन्झ मेटलर्जी फॉर मेकिंग डिफरंट टाइप ऑफ मिरर्स. इव्हन तुम्ही राजा महाराजांच्या म्युझियम मध्ये जरी आज गेले, इव्हन कोल्हापूरला महाराजा पॅलेस किंवा इकडे बडोद्याला लक्ष्मी विलास पॅलेस मध्ये अशा गोष्टी तुम्हाला बघायला मिळतात. इथं आमच्याकडे सोनेरी महल आहे, छत्रपती संभाजीनगर, डॉक्टर बाबासाहेब आंबेडकर मराठा विद्यापीठाच्या परिसरामध्ये, आपण या. सो hundreds of things are available in our history museum also. So highly polished bronze mirror are still made in Kerala today, just as they were in Harappa times. आता झिंक डिस्टिलेशन अँड मेटलर्जी हा सुद्धा पार्ट आपल्याला वाटतं नवीन, बट इट वॉज ऑल्सो ओल्ड. सो आय विल नॉट गो इन डिटेल, बट this zinc is also costly metal and it is very applicable, and this is the existence of our Indian knowledge system, and as well as in modern India, it was in old India or ancient India. Even woods in our periodic table, and every chemistry person know what is the significance of woods. That is, we can call it as tungsten, or W is the symbol of that metal. So you see, in this way, they made large number of ornaments or articles which is made by the process of making wood steel. And this is the proof which is mentioned in the literature. Even in another aspect, we are going to conclude our lecture, but even in social context, if we are looking in the history of our India or ancient period of India, most of India metal production was controlled by specific social group, including so-called tribe. Now, it may be said that nowadays the Manipur crisis is going on, and many people from North India, they are saying that that particular crisis is due to the existence of some very significant and precious metal which is available in the earth crust of that particular land, and that's why there is a dispute in between two communities, and that community is Naga community and Kukis community. So behind that, many people, they are saying that that particular struggle is due to that particular issue. Even it indicates by this particular first line. So this is controlled by the specific social group, including so-called tribes. त्या परिसरातले आदिवासी लोक, त्यांना वाटतं की आमचा हक्क आहे, आणि दे डोंट वांट टू इंट्रोड्यूस अदर पीपल. आणि या बऱ्याचशा गोष्टी तुम्हाला पाहायला मिळतील, की जसं अगारियाज ऑफ उत्तर प्रदेश अँड मध्य प्रदेश आर रेप्युटेड आयर्न स्मिथ. म्हणजे प्रचंड मोठ्या प्रमाणावर लोखंडाचे साठे तिथे आहेत. आणि आपल्याला सगळ्यांना माहित आहे की जेव्हा आपण अर्थ क्रस्ट मधून खनिजाच्या स्वरूपातून ते बाहेर काढतो, तर इतकी मोठ्या प्रकारात यील्ड आपल्याला मिळते. एकेकाळी आपण ब्रिटिशांवर अवलंबून असायचो, पण आज आपण एक्सपोर्टर झालेलो आहोत, आणि सगळ्यात जास्त आयर्न कुठे तयार होत असेल ते इंडियामध्ये. तर अशा अनेक गोष्टी याच्यामध्ये आपल्याला या पाहायला मिळतात. And another one thing, they contributed sustainability of India well, since India was for a long time a major export of iron. मी जसं सांगितलं तुम्हाला की एकेकाळी आपल्याला डिपेंड राहावं लागायचं, आणि इव्हन iron was also very costly. We have to purchase for the purpose. But later on, we get realized that in the many states in their land, there is a lot of ores of iron available, and we try to extract it. And nowadays, or as on today, we became a great exporter of iron for all over the world. Our iron is going to, एक काळ असा होता की आपल्याकडे टाचणी सुद्धा बनत नव्हती. आपल्याला असं म्हटलं जातं, आपल्याला नाव ठेवायचे की देर वॉज नो टेक्नॉलॉजी, नो सायन्स, बट इट वॉज दिस पर्टिक्युलर नॉलेज वॉज अवेलेबल इन द लिटरेचर. अँड नाऊ वी गेट रिअलाइज की असं नाहीये, आपल्याकडे टाचणी सुद्धा बनत नव्हती असं नाही म्हणता येणार. ब्रिटिश आपल्याला नाव ठेवायचे की ज्या देशामध्ये टाचणी बनत नाही तिथं कसलं सायन्स आणि कसलं टेक्नॉलॉजी. बट इज दिस पर्टिक्युलर लिटरेचर इज अवेलेबल इन ancient knowledge system. So India's iron and steel industry was intensive till the 18th century and declined only when the British started selling their own product in India while imposing high duties on Indian products. म्हणजे आपल्याकडे असताना सुद्धा ते आपल्याला जबरदस्तीने विकायचे. सो दिस वॉज वेन आपण जेव्हा गुलाम होतो त्यांचे किंवा आपल्यावरती राज्य करत होते, वी आर स्लेव्ह दॅट टाइम. So industrially produce iron and steel unavoidably put a final stop to most of India's traditional production. So this is one of the example I am putting before you, that is example of iron. But lot of metal, lot of alloys were prepared, were manufactured in the Indian history, Indian ancient period, and now we are globally exporter, become exporter of most of the metals, and due to this particular metallurgy system. And that's why the Indian knowledge system and metallurgy we can get correlate. And not only metallurgy, but Indian knowledge system, our chemistry, Indian knowledge system, our physics, Indian knowledge system, our nanotechnology. Now we are saying that nanotechnology, we are living in the age of nanotechnology, that is 21st century. But in those days also, many scientists, they were able to manufacture the gold nanoparticles, and they have painted that gold nanoparticle in many number of churches, many number of museums, glass windows, and that articles still it is available, which is made by uh, all over the country, even in our India also. And we can say it is not new. It was also old one. It was also ancient one. So this type of relation is there. Indian knowledge system we can apply for each and every walk of life, each and every field of life. Maybe science, maybe social science, maybe economics, maybe commerce, maybe management. And that's why it is very necessary to learn or to focus on the literature regarding the Indian knowledge system, which is available in the form of text, in the form of literature. And I want to give this particular message. Many more things we are saying that this is new one, this is modern one. But if you initially look into our knowledge system, that is in the medium of Nalanda and Takshashila University. So those universities were said to be called as a knowledge of ocean. Really, this was the knowledge of ocean, but anyhow it was demolished by that period by somebody, and that's why they try to uh, neglect our positive points, our knowledge system. But our duty is to look into this knowledge system and to take the benefit to proceed for the another generation. Thank you very much.
Thank you, sir, for delivering a very nice lecture on ancient Indian technology in the metallurgy. Now, participants are requested to ask any query, any question. The session is open for the discussion. Participant, please. I hope that there is no any query, any question about your lecture, because you have given information very deep way on Indian knowledge system, its vision, mission in Vedas, ancient period. Sir, you also told that the nail, now we are using the nail cutters. It was the ancient equipment, archaeology, mining, metals and alloy, zinc metallurgy, all these aspects you have told in a deep way. What was the ancient uh, metallurgy and how the equipments were made, and now the innovative ideas, these are compared that the ancient metallurgy is a good quality. So thank you for delivering a very nice lecture. On behalf of this Department of Chemistry, I am thankful to you, sir. Please. Thank you, sir.
So, thank you, Dr. M. N. Gaikwad, sir, Dr. Gopal Kakade, sir, principal of this college, and all the stakeholders of Dharur College, Rajmata Jijau College, Dharur. And I feel this is a great pleasure for me to have with you on the occasion of this national webinar. And thanks all the participants for listening me patiently. Thank you, one
sir.
and all.
Participants are requested the feedback link is sent on the WhatsApp group. You please fill the feedback form very carefully, and you will get your e-certificate on Tuesday. This link is open today only, so participants are requested to fill their feedback form because it is mandatory to get the e-certificate. Please. Now I request Professor Gopal Sagar to express the vote of thanks of this event. Over to Gopal Sagar.
Good afternoon, all of you. It is my privilege to present the vote of thanks for the national webinar on new horizons in chemical sciences. At the outset, I would like to express my deep gratitude to Professor Dr. Kishore Chikliya for his insightful opening remarks, which added immense value to this occasion. We are honored by your presence. I especially thanks to Captain Professor Dr. Suresh Gaikwad sir for his interesting and thought-provoking speech. Your expertise has inspired us, and we are grateful for the knowledge you have provided. I would like also thanks to our beloved principal, Dr. Gopal Kakade sir, for his leadership and constant support in making this webinar possible. A big thank to all the participants, including students, researchers, and faculties, for this enthusiastic participation. Finally, I extend my thanks to all organizing committee and the technical staff for their hard work behind the scene. Thank you, one and all. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you and congratulations, team Rajmata Jijau College, Professor Kakade, Professor Milind Gaikwad, and Professor Zogde and their team.
Okay, thank you, sir.
May I leave now?
Yes, sir. Yes, sir. Please. Yes.